In
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Campus Unesa, Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department, the undergraduate program of Physics and the undergraduate program of Physics Education. This is the profile of the undergraduate program of Physics.
Hello. In 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of physics. The undergraduate program of physics aims to strengthen physics educational that has already been established for a year. In line with the need of society and professional work field, this study program also experienced dynamic development. The study program from 3 area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating disaster, tsunami, and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by design of curriculum and research groups based on these 3 clusters, we want to prepare our graduate excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skills, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optic, Material and Characterization. Inshallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the physics department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between 2 surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator, that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment, different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the 2 photogates. The length between the 2 photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge discharge.
Karena itu tanggal 12 sore. Tanggal 12 sore. Ya.
Một triệu rồi. Sẽ ở đây rồi.
Ayo.
Tapi kok suara rincing, rincing dadak non durian.
AGP.
Loh, Pak? Ada kan? Bisa kok. Salah link. Pak juga Kak. Ada. Linknya juga Pak. Coba nanti kita
Cek, 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 cek.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Kampus Unesa Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department: the undergraduate program of Physics and the undergraduate program of Physics Education. This is the profile of the undergraduate program of Physics.
Hello, I am Munasir, the chief of the undergraduate program of physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of physics.
Variasi ya sinyalnya.
Baik, senang
Kan share screen ini kan enggak, terserah enggak, di 10 soalnya kecepatannya sih berapa? Yang berapa ya?
Apa frequency check?
been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optic, Material and Characterization. Insyaallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the physics department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration
Cek, cek.
aims to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Cambridge features pulse voltammetry measurements. In this laboratory of characterization, one of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, shrink pump and shrink drum collector, camera and LCD monitor, silica gel, humidity, and temperature sensor.
Udah. Ya, Kulono pakai tangan. Coba sih, kudo.
Kalau kami mendinginkanmu, apakah kami boleh lewat?
Source. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer that are using 3D printer.
Cek. Sudah masuk? Sudah ya? Baik. Baik, kita mulai. Sudah semua?
Ya, kurang dimulai kok, Pak. Belum dimulai.
Oke, Pak Alan. Sudah. Sudah? Oke. Oke. 2 menit lagi. Ya, semua kontrol dulu, dicek kembali. Barangkali ada yang OBS transisinya apa itu? Enggak jalan. Oke, Pak Kulik. Belum.
Good morning, ladies and gentlemen. Good morning, ladies and gentlemen. Welcome to the first international seminar on physics and its application, ISoPA 20 and 24. In this moment, we will announce some notification and refer to the general guidelines. We would like to inform all participants to stay on the screen and open the camera during the session using the ISoPA virtual backgrounds. For all the participants, please turn off the microphones during the conference, especially during the parallel session and the opening ceremony this morning. Please rename your Zoom ID using the format from the committee with the format name of institution _name, so the committee will be able to locate and identify the data of all participants that attend this morning. We would like to say thank you for joining us this morning at the first international seminar on physics and its application, ISoPA 20 and 24. And today, our seminar brings the theme of connecting physics to real-world application to realize the sustainable development goals in higher education. This conference today, thank you. This conference today is organized by the Physics and Physics Educational Department on August 10, 20, and 24. My name is Farah Shika, and I'll be your master ceremony today on the first international seminar on physics and its application, ISoPA 20 and 24. On this great morning, we would like to greet the Honorable Director of Universitas Negeri Surabaya, Professor Dr. Nur Hasan, and all of the Vice Rectors at Universitas Negeri Surabaya. The Dean of the Faculty of Mathematics and Natural Sciences at Universitas Negeri Surabaya, Professor Dr. Wasis, and all of the Vice Deans of the Faculty of Mathematics and Natural Sciences at Universitas Negeri Surabaya. The coordinators of physics and physics education study programs at Universitas Negeri Surabaya. Also, the Honorable, our keynote speakers, Professor Dr. Hiroshi Kawarada from Waseda University, Japan. Professor Endarko from the Institute of Technology 10 November, Indonesia. Professor Mirak Aydin from Trabzon University, Turkey. Associate Professor Muhammad Abdul Hadi Benyamin from University Teknologi Malaysia, Malaysia. Welcome to the delegates, participants, and keynote speakers for today's conference. This conference is organized by collaboration between lecturers, students, and the members of the Faculty of Mathematics and Natural Sciences at Universitas Negeri Surabaya. Ladies and gentlemen, let's start our first again, singing the national anthem of Indonesia. Those present in the room are asked to stand, please.
Kan lebih cepet lah. Lebih cepet apa?
Kak Marsunesa.
Those present in the room are allowed to sit down, please. Well, ladies and gentlemen, before we move forward to the next agenda, let us bring you to the beautiful traditional dance performance. The traditional dance, Remo Madya, will be conducted by a student from the Department of Physics at Universitas Negeri Surabaya, Nuria Amiratul Mahfuto. The time is yours. you, Duria, for the wonderful Remomadia dance performance. Next agenda, we will hear the committee chair report by Dr. Muhammad Satriawan. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Rector of Universitas Negeri Surabaya and all Vice Rectors, Dean of Faculty of Mathematics and Natural Science and all Vice Deans, Head of Physics and Physics Education Department, the Honorable Keynote Speakers, Professor Hiroshi Kawarada, Profesor Endarko, Profesor Mirak Aidin, Associate Profesor Muhammad Abdul Hadi Bunyamin, and also the Honorable all of invited speakers and dearest presenters and participants. First and foremost, let us express our gratitude to our God for His blessings, allowing us to gather here today for the International Seminar on Physics and its Application 20 and 24 by the team Connecting Physics to Real World Application to Realize the SDGs in Higher Education. We are proud to announce that this seminar has received an overwhelming response with a total of 570 participants, including students, teachers, lecturers, engineers, and practitioners who participate either as presenters and participants. We received 114 papers for publication that the authors come from 8 countries, namely Indonesia, Malaysia, China, Taiwan, Australia, Saudi Arabia, Japan, and Turkey. This diverse participation highlights the global interest and commitment to advancing physics and its application in achieving sustainable development goals. Ladies and gentlemen, I would like to extend my sincere gratitude to the speakers who have generously shared their time, knowledge, and experience with us. We are also grateful to the participants for their enthusiasm and interest in this event. Additionally, I would like to express my highest appreciation to the entire organizing committee who have worked tirelessly to prepare this event. Without your hard work and dedication, this seminar would not have been possible. I have not forgotten to thank the Faculty of Mathematics and Natural Sciences Universitas Negeri Surabaya and DRTPM Kemendikbud for supporting this seminar. And finally, I hope this seminar provides great benefits to all of us, expand our horizon, and foster further collaboration in applying physics to achieve sustainable development goals. Thank you for your attention and participation. May we all gain valuable knowledge and be able to apply in our daily life. That's all report from us. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Mr. Muhammad Satriawan, for the report. Next agenda, we will hear the welcome speech from the head of Physics Department, Professor Munasir. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Director, Universitas Negeri Surabaya, and all Vice Rector, the Honorable Dean, Faculty Mathematics and Natural Sciences, and all Vice, the Honorable Keynote Speaker, Professor Hiroshi Kawarada, Professor Enerko, Professor Mirek Aidin, Assistant Professor Muhammad Abdul Hadi Bunyamin, and the Honorable invited speakers and their guys, presenter, and participants. Good morning and welcome to the international seminar on physics and its application. It's great honor and privilege to address you all at this significant event where we gather to explore the theme connecting physics to real world application to realize the SDGs in higher education. This seminar, organized by the Department Physics, Faculty Mathematics and Natural Sciences, Universitas Negeri Surabaya. It is testament to our commitment to advance knowledge and addressing global challenge. The United Nations Sustainable Development Goal, SDGs, provide a comprehensive framework to tackling critical issues such as clean energy, sustainability cities, climate action, and quality education. Physics play a crucial role in bridging theoretical knowledge with practical solutions, enabling us to develop innovative technology and solutions that promote a sustainability and credible future. This seminar serves as a platform for bringing together brilliant minds from around the world. It's contributing unique perspective and insight. It is excellent opportunity for us to collaborate, share knowledge, and inspire one another to push up boundaries of our understanding and application of physics. Through the collective effort, we can make significant steps toward achieve the SDGs, particularly within context of higher education. Higher education institutions have a crucial role in shaping future leaders, researchers, and innovators. We have the responsibility to equip our students with knowledge and skill they need to tackle global challenge. By integrating the principle of physics with real-world application, we can empower the next generation to make meaningful contribution to sustainable development. I encourage all participants to actively engage in the discussion, ask questions, and challenge conventional thinking. Let this seminar be catalyst for exchange on collaborating that beyond few days. Together we can harness the power and physics create better future for all. As we embark on this intellectual journey, I extend my deep gratitude to the organizing committee for their hard work in bridging this seminar to fourth edition. I also want to thank all the speakers and participants for Their valuable contribution, your presence and participation will undoubtedly enrich our discussion, provide invaluable insight into the role of physics in achieving the SDGs. Without further ado, it is my great pleasure and honor of officially declare the international seminar on physics and its application is open. May this seminar be sure in inspiration, knowledge, and collaboration for all. Thank you, and I wish you all productive and inspiring seminar. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Munasir, for the warm welcome speech to the all participants, keynote speakers, and invited speakers on this morning conference. And thank you for your support. On our next agenda, we will hear warm greetings from the Vice Rector for Research Community Service, Innovation, Publication, and Rankings of Universitas Negeri Surabaya, Dr. Bambang Sigit Widodo. The time is yours.
Respected Rector of Universitas Negeri Surabaya, Vice Rector of Universitas Negeri Surabaya, Deans and Directors, keynote speakers in the International Conference of Universitas Negeri Surabaya, all the participants, and the esteemed committee of the International Conference of Universitas Negeri Surabaya. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Shalom, Om Swastiastu, Namo Buddhaya, dan salam kebajikan. And welcome to the International Conference Universitas Negeri Surabaya 2024. It's my great honor and privilege to welcome you all the International Conference Universitas Negeri Surabaya, supported by CONASPI 11 2024. This year, we gather under the theme Optimizing the Role of Universities in the Sustainable Development Goals, a topic of paramount importance in our rapidly changing world. Today, we had 10 international conferences, such as number 1, International Conference of SDGs and Bibliometric Studies. Number 2, International Seminar on Physics and Applications. Number 3, International Conference of Interdisciplinary Research and Studies in Mathematics. Number 4, International Conference on Innovation and New Paradigm of Sustainable Science. Number 5, International Conference on Applied Science and Vocational Innovation. Number 6, International Conference on Social Science and Law. Number 7, International Conference on Research and Academic Community Services. Number 8, International Seminar of Sport and Exercise Science. Number 9, International Conference on Education Innovation. And the last one, number 10, International Conference on Culture Studies and Applied Linguistics. As Vice Rector 3 of Universitas Negeri Surabaya, I am particularly pleased to see the enthusiastic participations of scholars, researchers, policymakers, and students from around the globe. Your presence here underscores a shared commitment to not only understanding the challenges of sustainable development, but also actively contributing to solutions that promote ecological integrity and social equity. Higher education institutions are uniquely positioned to lead the way in promoting sustainable practices. We have the responsibility to educate future leaders, conduct impactful research, and set an example through the management of our campuses. This conference provides an invaluable platform for sharing knowledge, best practices, and innovative approach to integrating sustainable into the very fabric of our educational systems. I would like to extend my heartfelt thanks to the organizing committee, our esteemed speakers, and all those who have worked tirelessly to bring this conference to fruition. Your dedication and hard work have made this gathering possible, and I'm confident that the insight gained here will be invaluable in advancing our collective missions. As we embark on this discussion, let us remember the crucial role we play in shaping a sustainable future. The decision we make and the action we take within our institution can have far-reaching impacts, influencing not only our students but also broader community and society at large. Thank you all for being here and for your commitment to advancing green environmental management in higher education. I look forward to the enlightening conversations and collaborations which will emerge from this conference. Let us work together to create a more sustainable, equitable, and prosperous future for all. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Bambang, for the warm greeting speech for this morning conference, and thank you for your support. Ladies and gentlemen, we will pray together before we begin this conference. Therefore, please have Mr. Setio Atmoko lead our prayers this morning.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Before we start this seminar, let's pray together. May Allah bless all of us. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadar Rasulullah. Allahumma sholli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Walhamdulillahi Rabbil Alamin. Allahumma inna nas'aluka salamatan fid din, wa afiatan fil jasad, wa ziyadatan fil ilmi, wa barakatan fil rizki, wa taubatan qoblal maut, wa rahmatan indal maut, wa maghfiratan ba'dal maut. Allahumma hawin alaina bis sakharatil maut, wa najiyatan minan nar, wa fa'indal hisab. Rabbana la tuzigh qulubana ba'da idh hadaitana wa hab lana min ladunka rahmah. Rabbana dhalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
The next agenda is the photo session. Dear all participants, please turn on your camera because we will take a documentation photo. Please, the operator, give us a sign when it's ready to take a photo. 3, 2, 1. Next slide. 3, 2, 1. Next slide. 3, 2, 1. Okay. Is it sufficient for the documentation session? That's great. Thank you. Dear ladies and gentlemen, this is the end of our opening ceremony. We will take a break for 5 minutes and be right back in a presentation session with the first and second keynote speakers at 20 past 9 Western Indonesian times. Thank you.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Kampus Unesa Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department, the undergraduate program of Physics and the undergraduate program of Physics Education.
Bapak Ibu yang hadir di
This is the
lokasi
profile
bisa
of the undergraduate
merapat ke
program
tempat
of
untuk duduk
Physics.
bersama di sela-sela break ini. Monggo Bapak Ibu.
Hello, I am Munasir, the chief of the undergraduate program of physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher
Monggo Bapak Ibu
to
untuk
be
maju
a
dulu.
university. This reformation led to the establishment
Evi,
of the
dibantu untuk
non-educational study program. We include the undergraduate
Monggo Bapak
program
Ibu
of physics.
untuk ke depan.
The undergraduate program of physics aims to strengthen physics educational that has already been established for a year. In line with the need of society and professional work field, this study program also experience dynamic development. The study program from three area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on analysis and development of software for mitigating earth disaster, tsunami, and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these three clusters, we want to prepare our graduate excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optics, Material and Characterization. Insya Allah, The infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the Physics Department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between two surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment. Different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the two photogates. The length between the two photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aims to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual-trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Gamris features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, shrink pump and shrink drum collector, camera and LCD monitor, silica gel, humidity, and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, hitting the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who want to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some salient points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic
Cek satu, cek. 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 Cek satu. Cek. Cek satu. Cek satu, cek. Cek.
Cek, masuk. Kenapa? Cek. 1, 2, 3. Assalamualaikum warahmatullahi wabarakatuh. Jelas.
Hello, ladies and gentlemen. May I have your attention, please? Our first plenary session is about to begin. Before we start, we would like to notify you again about the general guidelines. We would like to inform you to stay on the screen and open the camera during the session using ISoPA virtual background. For all the participants, please mute the devices during the conference. Don't forget to rename your Zoom ID using the format from the committee, including your names and your institution names. So, the committee will be able to locate and identify the data of all participants. Thank you. Well, ladies and gentlemen, now we have come to our first plenary session. Our first keynote speakers is Professor Dr. Hiroshi Kawarada from Waseda University, Japan. And our second keynote speaker is Professor Endarko from Institute of Technology 10 November, Indonesia. This session will be moderated by our moderator, Mrs. Enda Rahmawati. Good morning, Mrs. Enda.
Good morning, Mbak Farah.
How are you today, Mrs. Enda?
Great, thank you. Hope you have a nice morning too.
I mean, well then, and now we will see plenary session from Professor Kawarada and Professor Endarko, along with our moderator, Mrs. Enda. To Mrs. Enda, Professor Kawarada, and Professor Endarko, the time is yours.
Thank you very much, MC Mbak Farah. Bapak, Ibu, ladies and gentlemen who join in Zoom meeting and also who join in this room, good morning. And Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, first of all, I would like to welcome you to the plenary session 1 of International Seminar of Physics and its application ISoPA to 2024. And in this first session, we have two keynote speakers who already attend. Professor Kawarada from Japan joined in Zoom meeting, and also Professor Endarko already attend in this room. Bapak Ibu, this session will divide into two parts. The first session is the presentation from the keynote speaker, and the second one is Q and answer part. And for the first presentations, I would like to invite Professor Hiroshi Kawarada from Waseda University, Japan. I will say hello first. Good morning, Professor Kawarada. Can you hear my voice? Good morning. Professor Kawarada, you still mute your Zoom already. Good morning, Professor Kawarada.
Can you hear me?
Good
Can you hear
morning,
me?
Professor.
Can you hear me? Can you hear me?
Yes, it's clear.
It's very clear, Sensei.
Yeah, because my mute was not released, okay? So, because organizer stopped my microphone. So, yeah, now maybe you can hear. Can you hear me?
Yes.
Okay.
Okay, thank you. Before
So
we
I
start
got,
the presentations, I would like to read the short CV of Professor Hiroshi Kawarada. The operator, you can display the CV. Okay, I will read the short CV of Professor Hiroshi Kawarada. Professor Hiroshi Kawarada obtained his Bachelor of Engineering from School of Science and Engineering, Waseda University. And then he obtained his Master of Engineering and Doctor of Engineering in Graduate School of Science and Engineering, Waseda University. He has great experience in research. There is a big grand research here. He became a leader in advanced low carbon technology research and development program, and also become a leader in grant in aid for scientist research. And from 2022 to 2024, he became a leader in grant in aid for challenging exploratory research. And today he will present presentations with the title Protein Sensing Immobilized DNA, RNA on Diamond Fats. So in the next 30 minutes, time and stream are yours. Please, Professor Kawarada.
okay, thank you very much for introduction. Can you hear me?
Yes, we can hear.
Are there any problem for?
Sensei, maybe the spotlight of PPT or your
Can
I'll
you see the
show you what?
Can you see the PowerPoint in Zoom?
Yes, because the PowerPoint is now going on. No, I shared it.
Okay.
No, no biograph. I shared. I did share. So my presentation. Okay.
Okay.
Can you see my biograph? No.
We can see the PowerPoint. We
You
can hear
cannot
your
see, or
voice.
you can. You can see, or you cannot see.
We can.
You can or you.
Yes, we can.
So it doesn't matter to start. Please answer. Oh, could you please answer? Sorry, my microphone. So my biography is. You can see my biography.
Yes, we can see.
Okay, and this is the first biograph, and so can I start?
Yes.
So thank you very much for the introductions, and I'm so this is my. Thank you very much for inviting. I'm sorry to say that I couldn't go to Surabaya today because I have a still summer semester is going on, and it's almost end, but still the summer semester. So unfortunately, I cannot go to your country. So my title is Protein Sensing Using Immobilized DNA on RNA on Diamond Field Effect Transistor. If there's a problem, could you please say something? Okay. So this is the second biograph. Can you see my second biograph?
Yes.
Okay. So this is a biograph that I'm going to show you. I'm doing carbon, and which is very interesting material. And the structure of carbon, in this case, we call diamond, is the same as that of silicon. Okay. So the silicon and diamond have the same structure. And I started my research career from silicon semiconductor. And about 30 years ago, I changed to diamond. Okay. But I think there's no big difference. As you can see, this is a part of periodic table. And this is group 4 material, carbon, silicon, and germanium. Okay. So the silicon and carbon is very similar. Okay. So each other. So this is one advantage of diamond. And also the diamond is easy to burn. Okay. This is one big experience in 18th century. Do you know the scientist named Lavoisier? The French Lavoisier, the French famous chemist. And he founded law of conservation of mass. Very famous. Maybe you can find his name in textbook. But unfortunately, he was killed by in the French revolutions. So he found the diamond was made of carbon, okay, using this kind of apparatus. And he used big, this is a big lens, and focused sunlight, and then burn this material. And he found that it was made of carbon, okay? By using this kind of reaction, using lime water, and the product react, and then result is calcium, CO3, which is quite sinking. So they found that this is made of carbon. So the diamond is made of carbon and easy to burn. But also, this is very interesting because we can make a diamond by using a gas phase. Now using methane and CO2, both greenhouse gas, as you know. And of course, Indonesia is famous for the production of rich natural gas, the methane. So you can very easy to make a diamond from the byproduct of CO2 and methane. And the result is that you can see that to see it become diamond, then the only byproduct is water. So this is a very eco-friendly process. So using these gases, the amount of diamond you get, it depends on the size, of course, but for example, in 1 square centimeter, when it becomes 0.5 millimeter thick, then it almost 1 carat of the diamond, and it costs only $10 or less. Okay, and 2 inches is this much, and it depends on the machines that we're going to use. The machine we're going to use is the plasma-assisted diffusion system. And by using the composition of this gas, that at some precise temperature, then we get diamond. Not so difficult. So in our lab, we have several operators for this kind of machine. And but the mechanism of the diamond is to stabilize the sp3 bonding, okay, on the surface. So if the surface is covered by hydrogen, and the one layer can be replaced by metallurgicals from the composition of methane. And then we get one monolayer diamond, okay? So this is not so difficult to achieve. But the important thing is that to stabilize the surface, we need hydrogen. So hydrogen stabilizes the diamond surface. So there's a lot of ways, but one example is what we're using microwave plasma CBD and to get diamond by decomposition of the carbon source. And also we can use impurity like boron to get p-type semiconductor, which is similar to silicon. Okay, silicon also use boron as a acceptor to get p-type semiconductor. The same thing is true in the case of diamond because it has the same structure. And we get relatively large polycrystalline wafers, 4 inches, for example. Right now, it becomes so big industries. This is from the BBC News last year. And now India is a big industry emerged for the diamond glows. And that was very interesting because they have a lot of operators, sometimes more than 1,000 operators on the one company. And they produced a lot of diamond or gemstones or jewelries. And India's diamond gem industry will be very important source of the semiconductor industry, I think, because they make a lot of diamond, but the price of gemstones is going down. So they don't want to make more diamond as a jewelry, but they need another application. So I think this is kind of things happen, and then it will be great news for us to use the diamond as a semiconductor industry. So today's talk is on the using a diamond as a semiconductor, and then we're going to show you how it works as a biosensor, okay? Because this is a transistor biosensor made of diamond semiconductor. And the second subject is to get information with the biosensing. We use Optima, which is DNA or RNA, and it detects some of the special substance or proteins, okay? And if time remains, we are going to show you the merge sensing using a transistor biosensor. So why biomolecules in the solid surface? I think this is the very first questions to answer, because the solid surface interaction is normally not for biofencing, but the good thing that normally the reaction takes place in 3 dimensions, but we can confine or we can limit the reaction on the 2-dimensional things. So this is good for control the biomolecule reactions. So that's why we use the surface. The second one is why we have to use the carbon. The carbon is harmless for the biomaterials. What we call biocompatibility is good in carbon. But why diamond? Okay, this is the main questions I have to answer. The surface sp3 bonding is one of the reasons why we use diamond as a biomolecule sensing, because the surface of a diamond is easy to be controlled by many terminations, like hydrogen terminations or oxygen terminations, and also fluorine terminations, amino terminations. So many types of the termination. When we control the surface, it continues in air. So this is very advantageous of this type of the surface, because normally the metal surface is easy to be oxidized. The silicon surface is also the same. It can be easily oxidized, but diamond surface, of course, it is sometimes oxidized, but it is not oxidized like hydrogen termination or amine termination or fluorine termination. These are very stable. So we can use the very different type of the surface for the biomolecule immobilizations, or sometimes biomolecule doesn't stay, like fluorine termination, for example. So these are very different type of characters surface, and we can control. So diamond surface has a diagonal bond on the surface, but sometimes it's dominated by hydrogen, oxygen, or many other surface. Compared with the graphene is a imperfect graphene. The surface is very inert. So such a kind of immobilization can be easy to achieve. That's why the diamond has superior for the carbon the biomolecular immobilizations. And one of the examples that of the DNA has you can see this is the backbone of the DNA, and this double-stranded, but this part we can immobilize using linkers like that. And sometimes surface is terminated by carboxyl. Okay, so then it can be easy to immobilize using NH2 terminated surface, because the peptide bonding between this COH and NH2. So the many types of the immobilization of the DNA has been already tried. And we are using a relatively short linker to get DNA near the surface. So then, why the transistor biosensor? So the biosensor, before the biosensor, we are developing the diamond transistors. This is not for the biosensor, firstly, but now we found that it can be used for biosensing. So firstly, we're using hydrogen terminations, for example, and surface become p-type conductions. And then it shows the transistor operations at high temperature or very high voltage operations. We can get, because room temperature, we get very nice operations. And we are making, for example, high frequency device at that gigahertz operations, and we get the power. This is the power as a function of voltage, and high voltage operations we get high power density, and this power density is almost as large as that of silicon carbide. This is a green plot, and still lower than gallium nitride, because this is the one with the highest power density in the semiconductor at high frequency. But this behavior of our plot, you can see this star, it's more than that of silicon. Because that's why the diamond is better properties of the silicon, okay, in this case. So why we can use transistor as a biosensor, okay? So this is one of the example of the transistors we can use, and this is a source and drain, and in between that, there's a place for the example DNA immobilizations. And the good thing of this transistor is that once we shrink this like this, for example, if the chip size or device size shrink to 1/k, then areas for the chip size become 1/k square. And the sample volume is 1/k square or 1/k cubic, okay? So the sample size, the change, but this is a good thing of the transistor that these properties doesn't change. Okay, so this is a very important thing because this source and drain distance is shrinked by 1/k, but at the same time, this gate, so this width also changed 1/k, and then the property doesn't change. So this is the scaling rule of the transistor. That's why the transistor can be integrated, or transistor becomes so small, but it doesn't change its performance. So this is one of the merit of the biosensor of using transistor. So that's why we use the advantage of transistor, field effect transistor. And then when we compare it with silicon, okay, this is another comparison. We used silicon, this is the MOS silicon metal, but metal is not here because it's embedded in the big electrolyte solutions. So the electrolyte solutions, and then we need some protective layers, and gate oxide is located in here, but it has some thickness, more than 10 nanometers. However, in diamond, we detect biomolecules on the surface. So we detect the change of surface charge. And then this is one of the advantages of this kind of sensing mechanism, very surface sensitive. And the thickness becomes so small, then sensitivity goes up. And then this is one of the merit of the diamond surface, because diamond surface is chemically inert, the chemically stable. So it shows much better stabilities compared with the silicon transistor biosensor. So this is self-made transistors, which is relatively large, but we can, this is the handmade transistors, and this is very unique transistors. So the surface of a diamond is shown black, and we covered the areas by using epoxy, and this regions or this region is opened to the, then here is a gate. So this is a cross section of these devices. I said epoxy is coming like that. This is coming like that, okay? But these regions are opened to the electrolyte solutions. And also we need a counter electrode, so the gate electrode present here. So we apply the gate voltage, and also we apply the drain voltage. Okay. So when we change the gate voltage and drain voltage, the characteristics that we obtained in drain current and drain voltage is very, very good. I think it is very, very typical transistor actions can be obtained in the case of this transistor. Okay, so here we don't have the electrodes, but we put into the electrolyte solutions, and then we add gate electrodes, and then we apply the positive or negative ions to get transistor operation like this. Okay, this is a very nice transistor we can make. But this is very unique for the diamond transistors operated in electrolyte solutions. So we're using that, and also it's the same kind of, we're going to have to explain why this kind of transistor is better than silicon. Because you said the silicon has a relatively thick gate oxide, and this gate oxide, the capacitance in here become small, and then the carrier contributed to the biosensing is small. Then we get better current by the charge of, for example, DNA. The DNA is a negatively charged material because it has phosphate backbones. So we have highly negatively dense material. So we detected this charge. Okay. So the DNA has as you know, normally DNA has a famous, so it's double strand structures. But before that become double strand structures, they have a single structures also, single strand structures also. So when these sequences are complementary, then it becomes perfect double helix like this. So before, we call this the hybridizations. But before hybridization takes place, the charge here is half of the double strand. So this change of the charge increase by hybridizations, we can detect. Okay, so this is a change of this IV characteristic before DNA become hybridized. This is before hybridized, and then this is after hybridizations. So this is a very important change to detect the DNA becomes single strand from single strand to double strand. So this is okay. So this is a very important characteristic of this surface. So we normally recognize a negative charge in this case. So this is a mechanism that I show you, and then we get relatively so we are using a single strand DNA, and we have one base mismatch structures. Maybe this is really difficult to explain. Maybe somewhere I think I have okay, but that's what we want to say is that this is sensing by using fluorescence dye, not using transistors. And before that, we checked our reaction exactly takes place by using fluorescence dye. So these are combination of, if the DNA to single strand DNA is not complementary structures. Complementary means, I think there's some other examples to explain the DNA theory. I think it's better. So you can see that this is thymine and adenine A equal PA or cytosine guanine CG. Well, those combinations make a complementary DNA, but if the base is different, then there's no one missing takes place. So this missing we can detect by using DNA sensors. That's what we did firstly. So this is one base one mm is one mismatch. Only one base is missed. So the hybridization is not perfect. Then we can detect, okay, this is the only complementary one is detected, clearly, but now it's not like this. So this condition is relatively difficult to find, but once we find that, it's a very sensing, very accurate measurement we can do. So using this kind of condition, we also use for the first time to detect the one base mismatch compared with a complementary base mismatch using voltage change. Okay, so using the transistor characteristic. Because the fluorescence dye measurement is a classical measurement, and it's of course a lot of advantage. But if we can realize everything by using electrically, then it is very good. Okay, so that's what we did. I did it many years ago, but this was one of the first evidence that the transistor can detect such a subtle behavior. And then using this characteristic, we applied using DNA or RNA to detect other material like proteins, for example. So one very special structures of the DNA or RNA has some affinity to make chemical bonding. So each detect some very special proteins or substance. So there's one example that Dr. Ebi Schreiber right now is sitting here. It's very clear evidence that ATP detection by aptamer. So we used the double-strand DNA here, and one DNA is aptamer, become aptamer. Aptamer means it affinity to very special material like ATP, for example. So in this case, the double-strand DNA, but it has fluorescence in here, so we can see this pictures. And then it makes reaction between ATP, then the double strand has been released, becomes single strand, and this single strand aptamer DNA has a bonding like this. So then it escaped from its partner. So then what happens in fluorescence image is that used to be fluorescence located here, but it's gone. So we can detect this release. This has only happened when the ATP coming. Okay, other material doesn't show such a behavior. So that means when this light areas become dark, it means we could get ATP. Okay, so that was very, very sensitive, but it is very important detections. So she also tried that estrogens have the same kind of a measurement. I think its time is limited, so I think just we skip that. But the same thing is true because by using fluorescence dye, then we get the fluorescence dye of aptamer. But then estrogen reach these areas, then it take the aptamer and then make these air regions dark. Okay, so because aptamer has been combined with target estrogens. So other kind of proteins we are going to use is here's a PDGF, it's platelet-derived growth factor, and this is sometimes we can check of the tumor growth inside of the body. So this PDGF has a negative charge, sorry, positive charge. So once here we mobilize the optimals, and then it becomes such structures, and it holds optimals, sorry, PDGF, and then the charge become positive in this case. DNA was negative, but these proteins are positively charged. So then we get different peaks, the different shift of electrical current behavior. So we get this shift, and then we can measure this substance has been detected. Okay, so this is very reproducibly we get by using our FET. And as you can see, this is shift of the binding PDGF and then released, and then so this behavior is very reproducible. So we get very stable biosensing using transistor biosensor. This is another case because this is peptide proteins, and we can see this is oligonucleotide-rich regions. This means this amino acid has a positive charge. So these positive charge regions also we get here. So this is a little bit complicated structures, but this is the RNA structures. And then this combined with using other, this is the optimal, this is probe RNA optimals, and it combined make this kind of structures. So we also get, because this peptide has a positive charge like this, so we detect by transistor. Okay, this is another examples by using the large proteins with TOT protein inside. Okay, so this is one of the examples, but we tried many proteins or some other substance using DNA or RNA optimum. So this is very important for the biosensing, and we're still continuing that. But not only change the target, but also important is the multi-sensing. The multi-sensing is very important to realize, because there's not only one substance inside, but many substances we have to discriminate. So then we need a multi-sensing. Well, the multi-sensing concept is like this, because we provide the different sensing FETs like this. But in this case, we need a counter electrode, and this counter electrode is relatively large, and also sometimes this current so those reference electrodes have interaction. So electrically, we fix this at the same voltage, and we only get one gate, and then we share the gate, and we change only this sensing port, and this is what we call common gate structures. Because normally the transistor circuit we use common source structures, and then we need a different gate. But if we use a common gate, that means a common gate means this gate is grounded like this. And then we get completely independent operations we get. So this is the first time we realized in transistor biosensing. And people cannot understand its meaning, but we know the transistor circuit. So that's why only electrical engineering people can find this kind of operations. So this is our very nice advantage. So we have different examples like pH or chloride ions of the same chamber, same atmosphere, and then we detected like this using common gate structures like this. And what we have found that is that independently we can detect using two different kind of sensing. So this only two we did, but I think it can be used in multiple sensing in very near future. So this is just first trials, and now we are going to present at a conference, or maybe we're going to have a new manuscript, a new kind of result. So the sensing, multiple sensing is going to be applied. And another one is we used to normally gate like this, okay? But sometimes this gate has a problem. And also it is relatively large, okay, in some case. So instead of using this gate metals, we changed its vessel. So this is stainless steel vessels, which become gate of this transistor. And inside we have, for example, 9 transistors. So this outside of the cup, we just get the ground, and this behave like a gate. And it operated very well, like a pH sensing. The interesting thing is that this inner surface become pH sensing because the stainless steel has a pH sensing port. So if we use this DNA is pH insensitive, then we get pH sensitivities like this. So the pH sensitivity can be operated using inside of a vessel gate, which is very, very useful for the cooking, for example, or the tasting. Okay, so this application is very wide. So this is a very interesting for new approach for the food sensing, because sometimes the food is stored in stainless steel vessels. This is small vessels, but the large vessels, of course, we can use that. And then the food detections also can be used with this stainless steel surface. And this is one of the advantage of this kind of detection. Okay, so I think it's about time to stop. So just a simple summary we have. And DNA or RNA directing mobilizations on the surface, because it can be only achieved by diamond surface. And it is very, very advantageous for detecting. The SNPs is a single nuclear polymorph, is one base mismatch of the DNA when we used this the DNA sensor. Also, protein sensing we can achieve. And other material like DNA or RNA, ATP or some other substance we can measure by using a similar transistor. And the mulch point sensing also can be done by using this sensor. So I think the carbon sensor is very, very advantageous for using food or some other biosensing applications because the carbon is biocompatible. So thank you very much for your attention.
Give applause to Professor Kawarada. Thank you very much, Professor Kawarada. And please still join with us until the Q&A session.
Yes.
Okay. And for the next, we will invite the keynote speakers from our neighboring campus, Professor Endarko. I would like to invite you to the stage. Thank you very much. Okay. Before we start, I would like to invite the participants and the presenters in Zoom meeting. If you have any question in mind during the presentation, please type the questions and I would like to read at the Q&A session. Okay. Professor Endarko have already here with us in this room. So I would like to read his short CV. Professor Endarko PhD obtained his Sarjana Science from UGM Yogyakarta and his Magister Science from ITB Bandung and Doctor of Philosophy from University of Strathclyde, Glasgow, UK. And he has 5 research grants in 2023 until 2024, and most of them is about phantom anthropomorphic multipurpose. And today, he would like to share presentation about 3D print phantoms, implementation of education and research in medical physics. So, Professor Endarko, for next 30 minutes, time and place is yours, please.
Okay, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning and afternoon. Better I stand up rather than I stand. Okay, I will directly using my. Okay. Okay, I will start my talking. Okay, I'm glad to be here to present my experience and knowledge in 3D printed phantom. My topic in implementation of education and research in medical physics. Okay, this is outline my presentation today. I hope it's plenty time to explain all this meeting. The first and important of medical physics education, the evolution of phantom, introduction to 3D printing technology, benefit and 3D printed phantom, is study, challenge and consideration, future redirection, and summary. Okay. When we are talking about medical physics, we must know the scope. Medical physics is the application of physics principle to medicine. For example, this area in radiation therapy, diagnostic imaging, nuclear medicine, radiation protection, etc. The significance to ensure safety and efficacy of medical procedure, the critical in the development and optimization of medical technology. Why this is important? This high demand for well-trained medical physics is very, very needed in education. Need for comprehensive education training program and to keep pace with technology advancement. The challenge in current education is a limited access to practical hands-on training to traditional phantom often lack the relation functionality for effective learning. Okay, next we are talking about the historical evolution of medical phantom. We start in early beginning, early in 20th century, there's a phantom made from wax model. This early anatomic and medical educator. Then a simple wooden dummies, medical school and procedural training. And about the 1910 and 1920, is a basic phantom made it from rubber and textile, water bed and container filled water weather to simulate human tissue. Then, next milestone in phantom development. In 1930, we are talking about water field phantom, Lawson and Stan water, this one. Used to measure radiation dose, improve the accuracy in radiotherapy treatment. Then using plastic to create more durable phantom for repeated use in radiotherapy. In 1950, render phantom designed to mimic human tissue is usually in radiologic and radiation therapy planning. In 1917, in this years, development tissue equivalent material, because this tissue equivalent material very important to improving the accuracy of those measurements. Introduction render phantom in nuclear medicine for imaging and dosimetry. This for enabling more precise treatment planning. And then anthropomorphic phantom with removable section and interchangeable part. This is above for educational and clinical setting. Okay, next. The slideshow is a technological advancement. In 1980, using computer-aided software to easy to generate more complex and anatomical to resulting accurate phantom. Then development of modular phantom that could be customized for specific research. Okay. Then adoption 3D printing technology 2000 to create highly detailed patient-specific phantom based on CT and MRI data. This is integration digital phantom data into phantom design. The precise replication of complex anatomical structure for research and education. Okay, for example, this slide shows the traditional phantom material and their limitation. This is from wax. This is render phantom. Usually, this material, the traditional phantom from wax, plastic, gelatin, agar, water fields. It's a property use advantage limitation. It is stable, summarized. For example, for a wax, this is the first early century make a phantom. This early anatomic model is safe because it's using web, easy to make model here. Okay, comparison tissue equivalent material in modern phantom. Now, in modern phantom, using PMMA, VVA, silicon-based material, hydrogel, or written-based material. The table is summarized its property, use, advantage, and limitation. For example, when we are using PVA, this is have a property soft, flexible, high water content. This is used, for example, for surgical simulation, ultrasound training. Advantages if it's mimic soft tissue texture, biocompatible, etc. Okay, because we are talking about 3D printed phantom, it's good we are introduction to 3D printing technology. Usually in 3D printing technology, we have three different patterns here. First, deposition modeling, FDM, stereolithography, SLA, selector laser sintering, SLA. This is, for example, for left, middle, and the right. This is the cheap, then expensive to expensive. Usually in education, we can use FDM because of very cheap 3D printing technology. And the commercial material, we can use, for example, for FDM, this is PLA, ABS, PETG, nylon, polycarbonate. This is cost effective because it's, I think in Indonesia, a lot of store selling this printing. Yeah. Okay. For example, if we are want to design and fabrication process of 3D printed pattern, usually the first step, we collecting high resolution imaging data. For example, from CT, MRI, or ultrasound. Then digital modeling, we create precise 3D model. You can use AutoCAD, Mobis, SolidWorks, slicer, 3D slicer, etc. Then slicing, that means it's converting the 3D model in the second step into thin layer using slicing software. For example, using Cura, Prusa Slicer, then another software you can use. Then this section, this important section, then material selection, choosing the appropriate material because this is material can make this, the phantom is actual same or not in the tissue equivalent. Then 3D printing process, layer by layer construction phantom using 3D printer. For example, we can use FDM printer, SLA printer, SLS printer. The processing, removing support, then quality. This is important thing in here because it's very, very important. That means we testing and validating the accuracy of phantom. This is technological integration of modern phantom, digital modeling, imaging-based design, rapid prototype. This is from my labs. This one. Okay, I will continue. This is benefit and 3D printed phantom. Okay, for educational benefits, the first one is enhanced learning experience. It is enhanced learning. That means we are using 3D printed phantom to get realistic model because as you know, an anatomic human body is very, very complex. This means if we can create 3D printed phantom, 100% may be the same an anatomical model. This means we can give knowledge and enhance learning experience. The second one, hands-on training. This means a simulated procedure, error reduction. Enable students to practice surgical medical procedure in controlled environment. This is error reduction. That means the practice on 3D printed phantom have reduced error in actual clinical setting by improving skill and confidence. Interactive teaching using 3D printed phantom enhance the teaching. For example, customizable model. This educator can create specific model tailored to their curriculum, enhancing the teaching process. Then visual aids. This means effective visual aid for lecture, demonstration, and exam improving to students to get a more clear understand what they. And clinical area, 3D printed phantom give benefit, for example, for accurate treatment planning. Number one, for example, the patient-specific model, because we can custom phantom based on patient imaging data, enhance the accuracy of treatment planning in radiation therapy and surgery. And then pre-surgical practice, surgeon can practice complex procedure on expert replica of patient anatomy, improving surgical outcome. The second one, improve patient harm, enhance precision, reduce surgery time. Because in here, allow for more precise intervention, reduction the raise complication and improving recovery time. Then the last is cost effectiveness. Reduce procedure costs, minimize revision. Because it's accurate planning and the access to lower the likelihood of needing corrective procedure. Then, when we are talking about the research and development benefit using 3D printed pattern, the first, we're talking about fasting innovation. That means can make prototype testing, experimental model. The researcher can create custom phantom to test hypotheses and experimental procedure in controlled environment in facilitating innovation. Then collaboration and development and interdisciplinary research accelerate development. It is encourage collaboration between engineer, medical professional, and institution to innovate solution. Okay, regulator and compliance, this is standard testing and safety efficacy. When we are talking about safety and efficacy, ensure the new device and procedure meet safely and efficacy standard before clinical. Okay, next we are talking about case study and application. In this next few minutes, I only talking about what I have done with my student and colleague in our laboratory because it's have a limited time. For example, this one, we already developed a dosimetry evaluation treatment planning system in patient-specific 3D printed anthropometric phantom for breast cancer after mastectomy. This is 3D printed specific phantom for breast cancer after mastectomy. This is showing us a treatment planning system for radiation therapy. The second one did the same. Okay, did the same using 3D printed specific patient. We are want to know the impact three-dimensional conformal radiation therapy, fractionation technique, and on radiobiological effect, the risk on secondary cancer. This is our phantom for radiation therapy. This is treatment planning system using this phantom. Okay, another 3D printed phantom specific patient. We use to evaluation the 3D CRT radiotherapy treatment planning with radiobiological effect. This is a 3D printed phantom. This showing us a treatment planning system. This is ISoPA for guiding us to know what this is planning will to treatment this patient using this phantom. Again, we have been made is head phantom for influence normal tissue objective tool on treatment planning system in nasopharyngeal carcinoma. This is one. This is 3D phantom. This is 3D printed. Okay, another case study in radiologic diagnostic and interventional. This is a new publication for our lab. We already developed an evaluation allowed this pediatric chest CT examination using in-house developed various size pediatric chest phantom. This step by step, for example, this data from DICOM data patient, then we make in slicing, then we print it This is result from 3D phantom. This for pediatric phantom, 1 year old, 4 year old, and 7 year olds. The step to validate what is a phantom is good or enough, we making a measurement this phantom to validating things here. For example, in 1 year, 4 year, and 7 year, these organs, bone, etc., this decomposition, this phantom in host. For example, when we are comparing directly for city number, hospital unit in here, for example, for bone 1 here, decomposition have 51, then phantom in host, sorry, 510, this 512 phantom in host. And this 4 years and erect lungs is minus 536 minus. This is validating what this phantom do. Yeah. Okay, another phantom, the 3D printed breast phantom, analyze dual energy mammography extraction technique for the dose and image quality evaluation using 3D breast phantom. We fabricate 3D printed breast phantom to evaluate this dual energy mammography suppression. This is our phantom, 3D printed. This is mammography. Then we test it here. This is a picture from mammography. This is phantom 3D breast phantom. Another phantom, it's the same in mammography and ultrasound. We ready evaluation of physical properties, image polyphenol chloride as breast tissue equivalent. This is for dual modality, mammography and ultrasound. This is our phantom. This is resulting from ultrasound and from mammography. Okay, another case study in nuclear medicine. This we already developed thyroid anthropomorphic phantom for diagnostic and therapy in nuclear medicine application. This is thyroid. This is for male, and this for male. This we testing using radiopharmaca potassium 9 activity for thyroid phantom. I'm sorry, this you can see because if this table showing a comparison from directly using phantom and patient. Okay, another case for protection, radiation or radiation protection. This is evaluation of 3D printed anthropomorphic head phantom for calibration of TLD in eye lens dosimeter. This is 3D head phantom. This is head phantom commercial. We want comparison resulting the measurement for eye lens dosimeter. This is result showing us, I think this is good enough to comparable. If this is in-house phantom, this is a commercial phantom. Okay, next is challenge and consideration. Then when we are talking about 3D printing, this means we have challenge, technical challenge here. The first one is limitation, is resolution, speed, efficiency. Yes, resolution, this is the most problem. Then speed, see, it's challenging in here, resolution and speed. For example, we are talking speed, efficiency. Printing complex model can be time consuming, leading to inefficiency in product workflow. Impact, what is impact? The delay and model availability can hinder time sensitive medical procedure and research. It is issue with material. Yes, we have issue in material properties and durability. It's material limitation, durability concern. For example, phantom may degrade or less structural integrity after repeated use or exposure to sterilization process. Difficulty finding material that accurately mimic human tissue, mechanical and radiological properties. When we are talking material limitation, we have impact, affect the performance and the ability of phantom in simulating real-life medical condition. Okay, then overcoming design and fabrication challenge. This is complex design requirement, yes. Fabrication limitation. This is complex. This means creating detailing model for imaging data require advanced design skill and sophistication software. This is impact design complexity can increase production time and lead to error if not managed correctly. This publication limitation, when they are talking this here, this impact additional step increase production cost and time, reducing overall efficiency. Okay. Next, we are talking about regulatory and ethical consideration. Ethical implication of using 3D phantom. The first, patient concern and privacy, potential misuse. When we are using data from patient specific to create phantom, require careful handling of sensitive information here. Impact rise ethical concern about data about privacy and informed consent. And potential measure, this is impact required establishment, ethical guideline to govern the use 3D printed phantom. And ensuring patient safety and data privacy, data protection, safety protocol. When in data protection, think robust data protection is to secure patient information used in creating phantom. Safety protocol, this is in impacting, minimize risk and ensure a safe learning environment for medical professionals. Then when we continue talking about the cost and accessibility of 3D printed phantom, the first is cost factor involved in 3D printing. Yes, for an initial investment, I think they need high cost accessory 3D printing equipment. Operational cost, actually, yes, operational cost. Then accessibility of technology in different regions. Some part region difficult access this 3D printing. Strategic reduce cost, improve accessibility. We have 3 points here: collaborative effort, innovation in material, government and policy. For example, in collaboration effort, partnership between industry, academia, healthcare institutions to share resource and knowledge. Innovation in material development, cost effective and readily available material for phantom production. A future direction in emerging technology in 3D printing is multi-material printing. I think this material printing is very important for this technology because the development printer capable using multiple simultaneously to create more complex and realistic phantom, detailing anatomic and functionality here. Then nanoscale printing. This is advanced in printing nanoscale to create ultra detailed model that mimic cellular structure. This is give impact, enable high resolution model for advanced research and detailed medical. Then bioprinting, I think, yes, printing liver cell to create tissue and potential organ, offering groundbreaking possibility for medical research and treatment. Integration with other advanced technology, okay, this with AI, with the VR or AR, augmented reality, virtual reality. Using AI, for example, for AI algorithm, used to optimize a print process, design, customize, and methods. A virtual reality, augmented reality, for example, for integration with VR and ER for hands-to-critical simulation and training environment. There's a possibility innovation, smart material, and remote printing. Because when using remote printing, we can use expand accessibility and cooperation across border, fostering global and innovation. Next, research and development focus in 3D printing. This material innovation, yes, this is needing further research, material innovation. This is open to research in new material innovation for the 3D printing, yeah. Improving biocompatibility, mechanic properties, and cost efficiency. Functional quantum, this can focus enhanced realism on training model for more accurate and medical simulation. Standardization, we can focus creating guidelines for material properties, design process, and quality control. A collaboration effort and interdisciplinary project, yeah, actually, yes. Impact and foster and develop quantum that address diverse clinical need and challenge. A global partnership impact the accelerate advancement, border discovery research, and 3D printing. Academic industry partnership, okay. This is a can impact bridge the gap between theoretical research and real implementation. Funding and grant provide financial resources for cutting edge research and innovation. Long-term impact medical education, yeah, comparative learning, continuous learning. Potential transfer clinical practice is personalized design clinical innovation because impact improve patient outcome and reducing the risk complication. When we are talking about inspiring the next generation of medical physicists, we are talking about educational outreach and fostering innovation. Educational outreach impact cultivate interest and expertise in emerging technologies and medical advancement. Fostering innovation impact drive future innovation and maintain the momentum of progress in medical sciences. Okay, the last presentation is a summary. It's the first one, 3D printing technology is shown as the creation of quantum by proper and customizable high fidelity model for range of application. 3D printed quantum application and clinical practice, education and research, showcasing the role of quantum enhancing medical procedure training and innovation. 3D printed quantum offer unparalleled realism and can be tailored to meet the unique need of individual patient or educational scenario. 3D printed quantum have the potential to transform medical education, research, and clinical practice by offering precise, customizable, and cost-effective solutions. The last, the growing advance in 3D printing technologies promise to further enhance their unity, paving the way for future breakthrough in medical science. Thank you very much.
Applause to Professor Endarko. Thank you very much for the nice and insightful presentation from Professor Endarko and Professor Kawarada Sensei. And now we will continue to the Q&A session. Ladies and gentlemen, participants and presenters of ISoPA 2024, Please, if any question, you may chat in the chat box or you may raise your hand. I would like to invite Professor Hiroshi Kawarada to join in Zoom. We will continue to the Q&A session. Thank you very much. Okay, if there are any question? Yes, one question. Okay. Operator, please. The first question comes from Mr. Fahmi.
Cek, cek. Okay, thank you for your time, Miss Enda. Good afternoon, Professor Kawarada. Konnichiwa. Okay, I'm Muhammad Nur Fahmi. I'm for Physics Department, Universitas Negeri Surabaya. I will ask about how the mechanism of vessel gate can use a specific material if the sensor becomes insensitive with pH. Thank you.
Thank you very much. I would like to invite Professor Kawarada to answer the question directly. Please. You still in mute.
Okay. Professor Kawarada, can you hear my voice? I think your Zoom is still mute. Could you please turn on the mic? Please, the operator, turn on the mic of Professor Kawarada. Maybe please the
yes.
host turn on. Okay.
Yeah.
Okay.
The mechanism you asked me.
Can you hear my voice, Professor Kawarada?
Yeah, I can hear your questions. I could hear.
Thank you.
You asked me the mechanism, eh? Mechanism or the optimal mechanism? Optimal.
Mechanism of vessel gate.
So this is very difficult questions, but the sequence of base in single-strand DNA or RNA and sometimes hairpin structures or some three-dimensional structures, so which sometimes match to the structure of the protein or some other substance. So to find one aptamer for one protein take a long time. So many trials may change the sequences, then find finally. So to find aptamer for one special structure or special molecule is very, very difficult. So we are not doing that, but some specialists are doing that. So then finally they find a good combination of the sequence. Then we can reproduce because someone shows ATGC or ATAOT or those combinations someone find and then we can use. So this is a very time-consuming, but right now using some three-dimensional simulations to find some structures which fit to some molecules. So, but I think I only know this kind of things. So, yeah. Is that your questions? Okay.
Okay. I think your explanation is very clear, Mr. Kawarada. Thank you for your answer.
Yeah.
Thank you
So,
very much.
yeah. So I'm not developing after some special biochemist developing the afternoon. So I just use that.
Yes.
Thank you very much for the answer, Professor Kawarada. And I would like to invite any more questions from audience, from the Zoom meeting or from the room. Yes, one more question from Mrs. Ima.
Hello? Okay. I want to ask to Professor Endarko.
Yes, please.
For the research, I have interest with the research in 3D printing because as information in our laboratory, especially for instrumentation laboratory, we have a 3D printing there. And I was interested to develop our research in 3D printing too. Until now, diagnosis technology in medical application, especially for AI application, we have developed in simulation technology with high technology. But as you have explained that there is many challenges in the 3D printing research. So I want to ask, compared to the research using simulation, what the big advantage if we use 3D printing in the medicine, especially for diagnosis in cancer or others?
Okay, thank you for the questions.
Okay, thank you. It's interesting. If talking about this simulation and direct measurement, I think this is a different part. When we are talking in simulation, we can data for simulation. Then when we are talking directly measurement, that means the first thing to do that mean realistic model. For example, when use for generate a realistic model, there's been a lot of challenges. For example, for the head and neck phantom, that means we must understanding first is detailing anatomic and head and neck, the first. Then what the material is or for example, simulate and brain, for example, for nose and etc. That means a challenge because when we generate model 3D phantom, that means the problematic is that validating the phantom is actualization is similarly or not with detailing anatomic based on data, for example, using CT scan. This is challenging here. And when we are talking simulation, I think no, because we directly using the data from, for example, DICOM data. Using DICOM data, that means actually data from patient. This means just we need algorithm to processing diagnostic. This man, what the challenge is different in simulation and direct modeling generate phantom. I think this.
Is it answer your question? Okay, thank you very much. And the next question from Mrs. Effie, I would like to read for Professor Kawarada. What strategies can be employed to design a vessel gauge system for pH sensing that minimizes sensitivity to pH fluctuations? And how can this approach improve the stability and reliability of sensor readings in complex biological environments? Please, Professor Kawaradiam, would you like to answer the question? Can you hear my voice?
Of course, yes.
Okay.
Sorry, it takes some time to release my mute. Okay, so yeah, that is a important questions because pH fluctuations always happens in the in the electrolyte solutions. So when we use the same pH sensitivity in transistor side means the probe side, and then vessel gate itself has a pH sensing totally. But if we have a similar tendency of pH in the probe side, the sensing probe side, then it canceled. So this is a very good phenomenon. We found that because today we don't have time to show such things like that. But so sometimes probe and probe has a pH sensing, then these pH fluctuation can be canceled by the vessel gate. So the sensing vessel gate inside and the probe is completely works at the opposite way. So it can be canceled. So this is that. Then we add some other functions on the same probe surface. So then we get, for example, if we want to measure some other things like some other proteins, for example, but the total surface of the probe has a pH sensitive, then pH sensing can be cancelled by the vessel gate. So this is one good idea. We want to do such approach, but we don't realize it yet. But it's just idea. Okay. So, is that your questions?
Okay, is it answer the questions, Miss Evi? Okay, thank you very much for the answer, Professor Kawarada. And we have a nice discussion today, but I'm very sorry we have limited time. So I think I will close the Q&A session. And thank you very much to Professor Kawarada and Professor Endarko for your nice presentations and so insightful for us. And hopefully this will be provide many benefit for us. Thank you very much.
Thank you.
And I will give the time to the moderator, sorry, to the MC, please.
Okay. Thank you, Mrs. Enda, Professor Kawarada, and Professor Endarko for bringing us to a wonderful discussion that has been shared with us today. Also to the participant for the fantastic Q&A session. As a symbol of gratitude, the committee provides a token of appreciation for Professor Kawarada and Professor Endarko. Therefore, please have Mrs. Enda to provide the token appreciation for Professor Kawarada.
Okay. Thank you very much, Professor Dr. Hiroshi Kawarada, for your participation as keynote speakers at ISoPA 2024. Thank you very much.
Okay, next, please have Professor Munasir to provide the token of appreciation for Professor Endarko. Well, this is the end of the first plenary session. Thank you for your participation today. We will take a break and be right back in a second plenary session with the third and fourth keynote speakers at 11:30 Western Indonesian times. Thank you.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Campus UNESA Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department: the undergraduate program of Physics and the undergraduate program of Physics Education. This is the profile of the undergraduate program of Physics.
Hello, I am Munasir, the chief of the undergraduate program of Physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of Physics. The undergraduate program of Physics aims to strengthen physics educational that has already been established for years. In line with the needs of society and professional work field, this study program also experience dynamic development. The study program from three area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating disaster, tsunami and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these three clusters, we want to prepare our graduate excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill
including your names and your institution names. So, the committee will be able to locate and identify the data of all the participants. Well, ladies and gentlemen, now we have arrived at our second plenary session. Our third keynote speaker is Professor Mirak Aydin from Trabzon University, Turkey. And our fourth keynote speaker is Associate Professor Muhammad Abdul Hadi Bunyamin from University Technology Malaysia, Malaysia. And this session will be moderated by our moderator, Mrs. Mita Anggariani from Universitas Negeri Surabaya. Good morning, Mrs. Mita. How are you today?
Good morning. I'm fine. Thank you.
Thank you. Well then, and now we will see presentation from our third keynote speakers, Professor Mirak, and fourth keynote speaker, Associate Professor Muhammad Abdul Hadi Bunyamin, along with our moderator, Mrs. Mita. To Mrs. Mita, Professor Mirak, and Associate Professor Muhammad Abdul Hadi Bunyamin, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Thank you for joining us today in ISoPA 2024. I'm Mita Anggariani and I will be moderating this session. This session has two parts, the presentation and the Q&A. We have two marvelous presenters in science and physics education. For the first presentation, we are here to explore the integration of technology such as educational robotics into science education, specifically physics education. We are honored to have an expert in this field with us, Professor Mirak Aydin. Hello, Professor Mirak Aydin. Can you hear me? Can you hear me? No, not yet.
Yeah, I can hear you. Thank you for
Okay.
your
I hope I said your name correctly, Professor Mirak Aydin. Okay.
I hope so.
Okay. How
Thank
are you
you.
today? Are you good? Oh, you need
Yeah,
water.
I'm very
Okay.
good.
Okay. Before we proceed, let me introduce Professor Mirak Aydin to our audience today. Professor Mirak Aydin holds a doctoral degree in science education, and he is a lecturer at Trabzon University. His research interests and publications on using technology as educational tools, particularly in augmented reality, are very impressive. We eagerly anticipate his talk on educational robotics, which he will share with us today. I'm confident that we will find this session both informative and inspiring. Please join me welcoming Professor Mirak Aydin. The time is yours, Professor.
Okay, may I share my screen? Can you hear my screen?
Yes, it's very clear, Professor.
Okay. Hi, everyone. Thank you for your kind invitation to your symposium conference. Actually, the local time in my country is too early. It's 7 a.m. here. I'm so sorry for that because it's too early, but I will make a good presentation, I think, to you about my topic. I will, sorry. Oh, sorry. Is it more better?
Yes?
Yeah,
What is it?
thank
Do
you.
you have any technical issues there?
No,
No?
I don't have any problem.
No, we can hear
Okay.
you very clearly and you may continue your presentation.
Okay. Today, I will make a brief introduction about technology integration into science or physics classroom settings and how can we use educational robotics in STEM classrooms. Actually, let me know something more about my topic. I'm a professor studying at a university in Turkey, and my topic is how can we integrate educational technology into science or physics classrooms. I focused on lower secondary schools. We called them in Turkey at science education. I'm a science educator for focusing on lower secondary schools. Today, I will make a presentation to you about technology integration, but I think we have to remember overall aim of science education to understand what is the meaning of the technology integration and educational robotics. As you know, see on the screen, our aim is to bring almost all person in the society to bring a scientifically literate person, and scientifically literate person should have some capabilities. We consider these capabilities the overall aim of science education. Of course, there are a lot of definitions about science education, but the definition you can see on the screen by USAG is the, I think, most comprehensive one. Please take attention to the first aim. Our aim is to help students to explain phenomena scientifically. We know that there are two kinds of phenomena in the world. We can see natural phenomena and we can see technological phenomena. They are built by humans and we call them technological phenomena. So we have to teach students these technological phenomena beyond natural ones. I mean that we have to teach students the lunar phases of the moon, but we have to teach students why a door open without touching anything, a handle. We have to teach students why a light comes on without touching a switch on. We have to teach these kind of technological phenomena. I think we have to understand this truth, align with the science overall aim of science education. So we have to teach. We know science education is has really close to the
I'm sorry,
technology.
Professor Aiden, I'm sorry, but your slides still freeze, so we might difficult to follow in where your presentation state is. Could you please check your slides?
Yeah.
Yeah. Okay.
Okay. Okay.
Can you put it at a slideshow?
Okay, can you see it?
We can see it, but if better if you can put it as a slideshow.
So.
Oh, okay. It doesn't really matter. Okay.
Okay.
Yeah. I think that's great. Thank you very much. You may continue, please.
I hope you saw this presentation, this slide, or this part. So we can go on. We have to students technological phenomena. So what are the most important technologies in the world, and which technologies we can use to teach students? You know, there are several reports published by associations, science associations or technological associations. And the last report, some 10 technologies is really important in 2024. These are mobile learning, artificial intelligence, augmented reality, virtual reality, gamification, wearable technologies, and like this. These are really important, and we have to use these technologies in 2024 to help students understand technological phenomena. So, but we have to know that technology is important, but more important is integration of technology. This truth described by Blumenfeld in 2000, and he articulated that while technology offers numerous advantages, the manner in which it is utilized is a more crucial predictor of educational outcomes than the mere presence of technology. It means that we have to use technology to teach technological phenomena, but integration and using of technology is more important than technology itself. So I want to show you a more recent published bibliometric analysis by Chinese researchers about integration of educational technologies and the current state about it. This paper published in the last February in the journal Nature, and we can see some countries focused on improving the quality of educational technologies. You can see England, the United States, Australia, China, and so on. The importance of educational, the integration of educational technology is really important for these countries. And you can see some important insights from this paper. For example, you can see some universities that really focus on integration of educational technologies into real classroom settings. You can see some universities in Australia or England or north part of the Europe. I want to show some truth that you know that some countries in the world create high quality technology. Which countries are there? You know, north part of countries on the north part of Europe, Canada, America, and like this, these countries are really these countries create high quality technology. And we understand from this paper that these countries also consider the integration of educational technology. And another table published in this research showed that some journals really concentrate on educational technology. You can see the names of the journals on the table 6, Education and Information Technologies, Computers and Education, Bureaucratic Journal of Educational Technology, and so on. So this paper concludes that technology is a key factor in making education more powerful and improving learning outcomes. And the research presents a clear and valuable reference for researchers and educational practitioners concerned with technology education application in a theory and practice. So our real question is that how can we use education technology in the classroom settings? In other words, types of information and communication technologies used in education. We know that there is a well-known classification by chemists in 1977. It's a bit old, but researchers have been using this classification and we know instructional paradigm, revelatory paradigm, conjectural paradigm, and emancipative paradigm. We can use this paradigm to integrate educational technologies into science classroom. It's really difficult for me to explain the details about this paradigm, but the more important is another paradigm which we can use to integrate educational technologies into real classroom settings. This is STEM. You know, STEM is a notion which has been created for the last 20 years, and this notion have been affected almost all science curricula or physics curricula all over the world. And STEM notion also help us to integrate educational technologies into real classroom settings. In this notion, we can see some assumptions that STEM is more than just a collective of the 4 disciplines. The workplace requires STEM skills than ever before. The educational system has failed to bring up next generation, and until STEM, a comprehensive reform did not happen. This paper, published by editor of School Science and Mathematics, and this editorial was created in 2012, and then the editor created another editorial paper when she left the editorial position of the journal. She wrote in his paper, in her paper, that STEM notion is really important, but there are substantial problems in integration of STEM notion in the classroom settings. There are several points, several problems, but the most important thing, how can we integrate technology and engineering to the classroom settings, is still an important issue, an important problem. According to the literature, we found that educational robotics can solve this problem, can address the gap. By using educational robotics, it is really possible to integrate technology and engineering to the science or physics classrooms. You can see a paper created by Next Generation Science Standards in a framework for K-12 science education, and it helps us to understand the notion of STEM. This paper concluded that STEM is a notion which helps students understand scientific knowledge with 2 dimensions. The 2 dimensions is related to how to obtain knowledge, and the second one is how can we use this knowledge. I try to simulate this notion on the screen. I hope you can see it. With my research group, we created this simulation, and you can see the STEM notion here. You can see a scientific knowledge sample. For example, molds love wet conditions and grows where there is constant moisture. This is a scientific knowledge. According to the STEM notion, we have to teach students how this knowledge created, how is knowledge obtained, and how can we use this knowledge. According to STEM, we can use these 2 dimensions. Educational robotics can be used in the second part. In the second part, it is possible to use this knowledge with the help of some kids and creating a powerful problem-solving settings for students. For example, in this example, we created a problem-solving setting for students, also for teachers. You can see those are moles seen on the walls. How to eliminate moles that grow on the surfaces. This is a well-defined problem and driving question, and it is possible to answer to question with using educational robotics technology and using these knowledge. I want to show you detail more about it. Sorry. This is the first part. This is related to the first part. How can we obtain this knowledge? But I think we don't have limited time. This is the second part. It's an example about integration of education technology with STEM teaching and learning setting. These are the problems we created for students, and these are the solution. In the solution, students or teachers use the scientific knowledge and educational robotics kits. You can use some pictures when teachers trying to solve this problem, trying to use this solution in a professional development course. And this is the solution. In this solution, we use a humidity sensor, a DC motor. It stimulates a ventilation. I mean that to solve the problem, I mean that if you want to get rid of molds, you can use a ventilator to remove the moisture from the air. So it's a good solution. It's a plausible solution, but we need to control the ventilation because we know that according to World Health Organization, if the level of humidity exceeds 55%, you can see moisture everywhere on the wall, on the surfaces. So you have to create a system that it is prevent to increase the humidity level from the point of 55%. So this is our students or teachers' solution to this problem. The humidity sensor measure the relative humidity on the air and send this data to microprocessor. And if the level exceeds 55%, the ventilator starts to run. Otherwise, it doesn't run. You can see the algorithm created on the robotic kits, and it is a good solution to this problem. And we created this solution for International Journal of Science and Mathematics Education. If you want to read more about this solution, you can read the paper on the screen. You can see on the screen. I want to show you some details about educational robotics or the sample concepts of robotics, but I think I don't have any time about it. So if you want to know more about it, you can write to me. You can communicate with me. I want to show you other papers we created for students or teachers. Okay, this is our system educational research system education and robotics research group. We have 5 researchers, a mathematics educator, a science educator, a physics educator, me, and an engineer, and computer scientist. We created these solutions and write for reputable journals. For example, in the solutions, we try to control the pH level of water for provide good learning conditions for goldfish living in an aquarium. And you can see one of our meeting, we are discussing how can we create an environment for students to integrate educational robotics into real settings. And it's another example. And you can see a screen we created for teachers. They are trying to answer to the question we provided for them. And we also created some solutions for teaching earthquakes. In this project, in this paper, we made a collaboration with Nimin Yuryanti. She is from University Pendidikan, Indonesia. She was a good collaborator for us. We created some solutions for students. You can see some problem-solving settings. For example, how can we design an earthquake early warning system with Arduino technology? They created, tried to solve this problem on the online settings by using Arduino. And the second problem-solving setting for students, we created a gas detection device, utilizes Arduino technology for rescue teams to mitigate the risk of gas-related fires following an earthquake. These are really good quality educational robotics integrated STEM teaching and learning settings and examples. Nowadays, we have been studying for mathematics teachers, and our aim is to understand teachers mathematical reasoning. We try to understand, we try to measure teachers mathematical reasoning in an educational robotics integrated STEM teaching and learning settings. This is really important for us because these skills are important for mathematics teachers, and we know that if you want to integrate a new trend and emerging technology into real settings, you have to teach it to teachers. So we try to teach these skills with the help of educational technology, especially educational robotics in this example. Okay, thank you for listening. If you want to ask more about solutions we provided for students or teachers by using educational robotics, you can ask. Thank you again for listening to me. I am so sorry. The time it's really early here. It's it's uh, it's 7 a.m. I'm not really concentrated on the presentation. I am so sorry, but I hope we can make good conversation or discussion about integration of educational robotics. I am thank you again for your listening.
That's very interesting presentation, Professor Aidens. I think while I'm listening to your presentation, I'm inspired by your presentation. Maybe and
I'm
my
sorry,
colleague
I
here.
cannot hear you very well. I'm so sorry.
You can't
It's
hear me?
it is possible to increase your voice. Is it
Okay,
possible?
okay.
I'm so
Can you
sorry.
hear
I
me now?
cannot hear you very well.
Can you hear me now?
Yeah, I can hear you.
Okay. I said before that your presentation was very interesting, actually, Professor Aiden. It is inspired me, actually. Maybe we could make a research collaboration with our colleague from physics instrumentations to develop such a learning media, just like what your presentations was, something like that. But
We are open to make collaboration. We are open to join
yes,
research.
that's very
As
interesting,
I
Professor
explained
Aiden.
earlier, we made a collaboration with Mimin Iriante from University Pendidikan, Indonesia. It was a good collaboration for us. She helped us. How can we teach earthquake to undergraduate? She helped us, and we used this knowledge and created powerful learning environment by using educational robotics. It was a good experience for me, and we created a good paper in Journal of Science, Education, and Technology. It was a good experience for me.
Okay, well, that's really great. Okay, before we continue to the question and answers part, we still have one presenters today. So our previous session, which I moderate, is like very amazing, isn't it? Very interesting presentation from Professor Aiden. I hope everyone is still feeling enthusiastic. Next, we will discuss justice and equity in physics educations. It may seem unusual to link physics, justice, and equity together, but it's essential to consider how they are connected. Today, we welcome Associate Professor Dr. Muhammad Abdul Hadi Bunyamin from University Technology Malaysia. Dr. Bunyamin, are you already join us? Dr. Bunyamin? Is Dr.
Sorry,
Bunyamin?
I cannot open my video. I think I need
Okay, can you hear
permission.
me? Hello, testing.
Hello?
Hello?
Yeah.
I can hear you, but I need to open my video.
Oh, okay. All right. Again, can you hear me?
Yeah, I can hear
Okay.
you,
Okay, it's very good. Okay.
but I cannot open my video. I cannot open my
Yeah.
my scene because I need a permission to open it.
Yes. So Dr. Bunyamin already joined us today, isn't it?
Anyway, you can ask.
Okay. So Dr. Bunyamin's insight will deepen our understanding of justice and equity in education, shedding light on essential aspect of providing quality education for a brighter future. Let's all give Associate Professor Dr. Muhammad Abdul Hadi Bunyamin a warm welcome. Dr. Bunyamin, the time is yours.
Okay. Thank you, Mrs. Chairman. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning, good afternoon, depending on your time zone. I was in Malaysia now. My time is 12:37 p.m. 1 hour ahead of WIB. Okay. Alhamdulillah. Thank you for inviting me for this keynote presentation. Okay. Actually, I was just invited yesterday because one person cannot deliver the keynote session today. So I hope I can give my very best to you, even though I should say that I was given less than 24 hours for preparations. Okay. But I don't think I should sacrifice the quality of my presentation, even though I should admit that the time is not just very long. Okay. As the chairperson already mentioned to you about the topic that I will be delivered today, and I think today would be a best day for us to know or to learn something that might not really familiar with us. Okay, so I will start sharing my material. Okay, can you see my slides?
Yes, it's very clear.
Okay, so our topic today is about equity and justice in physics education research and practice. This is something that I should say that, as I mentioned to you, is quite uncommon for physics education researchers or even the students, probably because we did not really have a sufficient exposure to this topic. Okay. And I should say also that I got the inspirations of learning this research topic when I was in the United States, doing my PhD in the University of Minnesota from 2013 to 2017. And during that time, I learned too many information that I should say that I did not get it even when I was in my hometown in Malaysia before that. So a lot of things that I learned when I was in the United States until 2017, I think that it could be a good thing for me to share to all of you. Something that may not be able for us to hear often or always. Okay. This is a picture. I'm not sure if it is the best or the most appropriate. So the two words that we may heard quite usual: equality and equity. I may think that the word of equity, something that more relevant to say about, and I'm not to say that I'm the advocates for equality, because for me, okay, in order for us to have an equal opportunity, it is the question about equity rather than equality. Okay, and if you see there, the three person, okay, with the different heights, okay, someone who are taller and someone who are more shorter, okay, they need different supports, different interventions, different kind of assistance, maybe from the government for them to get the excellence in their life. So this is how I can say the way we portray the terms of equality and equity. However, when we see the equity and justice at large, especially in education, sometimes I feel that we often take it for granted, even though this issue is something that might have a huge implications to our society. So one evidence that I think I can bring to you is that for many politicians, especially when we are in the election year, they will start playing so many equity-related issues related to education or even the economics. Why? Because they know that people will get attracted to that manifesto, especially if they are the advocacy for equity and justice for the society, for the voters. But is it something that educators really care about? So that's the question that I always ask myself, myself, and also my friends. Do we really care about equity in education, or specifically in physics education? Because we know politicians are just very, very eager to fight about it because they need the votes from the people. But we educators, we don't need the votes anymore. It is not our job to get the votes. We are not the politicians. However, do we really think that we just simply pass the baton to the politicians to fight for the justice for the society? It should not be that. We are the one who should be the factor for the equity and social justice in our education. Okay, so that's one thing that I think the importance of bringing this issue to the center of education, especially in physics education. So in a broader sense, we have so many kind of equity and social justice in science or STEM or physics education, more specific, okay, such as race and ethnicity, gender, language, special needs and talents, urban education, rural education, culturally responsive science education, and so on. So today, I will just give a more emphasis on the gender equity, okay, to give more clear focus on how we can understand this issue from physics education perspective. So, usually in physics education, okay, boys have a huge number compared to girls, especially for physical sciences that usually cover the physics. But we know for many countries that the girls are more tending to the life sciences compared to the boys. This is quite true, I think, either in Malaysia or even in Indonesia, okay? Because people will think that boys are more likely to enroll in physics compared to girls, because girls are more, have the tendency for the biology, for instance. We have no answer why that's happened, but we can expect that it is a global phenomena, even it's happened in the United States. And also for elite students, okay, they are the one who regularly be the science or the physics student. But for some other students, they feel afraid to take the physics or the science in general. So there must be a question why this happened, especially if we know that boys are more in number compared to girls in the physical sciences, comprising the physics. But the case is different for the life sciences, covering the biology, for instance, that more girls are there compared to the boys. Okay? I think that it could be something, a good reflection to ourselves as a physics student, as a physics educator, even though I'm not sure if, okay, you can see yourself either, are you the physics person or not the physics person? Okay. And personally, I think that I start to have the interest in physics when I was in my pre-university level. Okay. And how I identify me myself as someone who can do the physics. Okay. Because probably, maybe, because simply I am a boy. I'm not sure if that's the case. But if it is also true for you, then I think there is no surprise. This is something that a global phenomena, not just in Malaysia, Indonesia. Okay, right. So this is the critical question again. Okay, is the community of physics education really care and concerned about equity and social justice issues in education, especially in physics education? Okay, I do not want to be providing the answer, even though I know it. Okay, and because we already passed the era of COVID-19 pandemic, okay, one thing that we can say that, okay, based on a research done by the scholar by Bailey and the colleagues in 2021, is that the pandemic has created a larger gap in education, especially the rich and the poor students and families. Okay, so this one particular issues in equity and social justice related to the pandemic of COVID-19 that created the messy situation around the globe. Okay, right. So again, as a physics educator or as a physics student, do we think that we have good, something that a good care about equity and justice in education? So it's really about the reflection to ourselves. Okay, and I should say me personally, okay, only have this awareness when I studied in the United States. I got the exposure from the instructors, from my lecturers, from my supervisors, who always talk about this issue. Unfortunately, this is not something common in even my home country. Okay, there is no particular interest in this particular research topic until I returned from US back to my home in Malaysia, bring this topic to my PhD student, and the faculty get surprised because my student is the first student who investigate the issues about equity and social justice in physics education. That's, I think, the value about bringing this issue, because this is something, a very uncommon topic in many physics education research. Okay. So if we want to learn more about the notion on equity and social justice, I can provide you some, or maybe specifically two notions or two concepts, or could be theories. Okay. Culturally responsive pedagogy, CRP, or funds of knowledge, FOK. Okay. So I don't want to elaborate more about these particular notions, but in general, I can say that CRP, culturally responsive pedagogy, is about how to make our pedagogy, our approach of our teaching and learning, more relevant to our students' culture and background. For instance, when we are teaching the topic about, let's say, the force and motion, the momentum, how we can relate the momentum with our students' culture and background. Okay, maybe for some of the students, they come to the school by riding motorcycle by themselves. They actually apply the momentum when they are riding the motorcycles or even the bicycles, for instance. Okay, so the teachers will need to know actually how to use this real life application of the students, that they actually or often use physics in their real life, even though they do not know, they really apply the physics in their life. So the teachers must make the awareness for the students that actually this physics is really close to our life. This is not something that the super theories that we cannot simply understand, like the modern physics of relativity and so on. This is a very simple physics that actually we bring and we apply in our life that culturally relevant to our society and maybe our nations. Okay, that's for the CRP. For funds of knowledge, also related to this one, it's simply about how we can use whatever resources, whatever knowledge, skills that students already have in their life, including their experience, and we bring it to our classroom. For instance, if a students have going to any beach for the picnic with their families, and they actually apply the concept of wave, for instance, okay, the water wave, and it can be used as one particular example on how we can understand the wave topic in the physics. So actually, CRP and FOK is really about knowing what are the experiences of these particular students that the teachers should be able to know and use it in the teaching and learning process, rather than just simply relying on the textbook provided by the government, for instance. Okay, right. So if we want to bring more the issues of equity and diversity in education, I think that physics can provide a lot of skills and knowledge that students already know in their life. They are not distant from physics. They actually apply it in their real life, but they do not know it is physics. That's the issue. Okay, so if you want to know more about CRP, it's a framework for educators to teach science or STEM in general to diverse students cultural in terms of the ethnicity or even the languages. And I think this is particularly relevant for Indonesia because you have so many race, religions, tribes, and even the locality based on this race and religion. Some locations are more Muslim majority. Some could be Christian majority. How we can capitalize all of this diversity in order for us to inform and enrich our teaching and learning, especially in physics. Okay, and for the FOK, the funds of knowledge, historically accumulated and culturally developed bodies of knowledge and skills essential for household or individual functioning and well-being. As I mentioned to you, okay, we can use the student experience that they already have in their real life in order for them to do physics in their school. For instance, if they are a swimmer, for instance, they regularly go to the swimming pool, they actually apply the buoyancy concept when he or she is swimming. So why not we use that experience in order to us, for the teachers, to enrich the teaching and learning of physics using this student's experience of swimming at the swimming pool, for instance. It's a the easiest way to understand these two particular notions, CRP and FOK, and how it can create a sense of, how we can connect physics in the real life and how we can ensure that the voices, the experience of the students are well appreciated by the teachers who teach physics, especially. Okay. So I want to come up with two perspectives, especially on gender equity. Okay. First, on the literature on the gender equity, the first dimension is more theoretical and conceptual, and the second one is more practical and tangible, especially because I use my own experience teaching physics with the lens of gender equity. Okay, so two perspective, theories, and also the practice, because I know that we cannot just rely on the theories. We also know how to realize, how to apply this theory into the practice. So I will use my own experience teaching physics with the lens of gender equity, especially when I was teaching this particular student groups in 2021. Okay, so this is the theoretical part, okay, where I made review of literature with my students, Izzah Mardia, my former PhD students about gender equity in science education, where both of us make the review from 2010 to 2020, the past decades of physics education, equity, and social justice issues, especially in gender. We mainly rely on Web of Science and Scopus databases, but also we add some more because we want to have a balance of the Western and also the Eastern, including Malaysia and Indonesia, in order for us to learn and to know about the trends of gender equity research and theories. Okay, and we focus more on the intersections of the culturally responsive pedagogy, CRP, the gender, and also the science, specifically the physics, including the physics. And this is the publication that me and my student, my former PhD student, published in 2022 about CRP, STEM, and gender equity. And if you see there, it is edited by Professor Lilia Halim, Professor Murni Ramli, and Professor Muhammad Norawi Ali. All of us work together for this book chapter, Culturally Responsive Science Pedagogy in Asia, Status and Challenges for Malaysia, Indonesia, and Japan. So it's actually 3 countries that we covered, because we know that in order for us to have a greater impact on equity and social justice in Asia, we should include more than just one particular country. So that's why we covered Malaysia, Indonesia, and Japan. I think you can get this book online. You can make the order online because it's already available in the market since 2022. Okay. So this is the first finding, that we, me and my students discovered, when doing this literature review, where usually girls' achievement in science was typically low in the standardized tests. And also we can also discover that girls' problems in STEM education could be tackled with the issue with the use of curriculum and teaching that consider girls' interests and also the learning preference of the girls, because we know that girls have a lower number in physics compared to the boys. So there should be the curriculum and teaching that take into account the girls' interests and also their learning preference in order for them to get interested to take and to learn the physics. And also, we made some further review, and we can see that some of these researchers, they conducted the research with the science teacher. And for instance, Pringle in 2020, he closely collaborated with the teachers who are teaching in the schools in order for them to together solve the issues on gender equity in the actual setting. So this is not just a typical academic research done by usual academic researchers. This particular researcher come to the school and did the research together with the teacher. It is not for the teachers, but it's actually with the teachers. So this is something that if you are familiar with the participatory research, one of the types of research that are available is the participatory research, where we do the research together with the teacher, not for the teacher or something else. We work together in order for us to have a greater or a better picture about the issues about gender equity in the actual settings. So this is something that quite different with so many academic research, because most of time academic research do the studies for the teachers. So this is something that I think a good move, a good dynamic by the current researchers, because they now realize that it is good for us to do our research with the teacher instead of do the research for the teachers. Right. So I think that the second finding from our analysis the issues on intersectionality. Okay, what does it mean? It is about the intersection of multiple identities. For instance, gender and also the race. Okay, it could be religion, it could be the locality, and so on. However, okay, we discovered that many studies, when they include the gender as one of the variables, they simply use it in order for them to get the demographics of the respondents, of the research participants. But they did not explicitly and in-depth make a study that can also give the enlighten about the issues on gender equity in that particular research topic. That's one issue. And whenever they do the research on race and gender, they usually have more emphasis on the race compared to the gender. So it is an imbalanced perspective, I can say it, an imbalanced perspective between race and gender, because most of these researchers, they are more inclined to study about race, the race, instead of the gender. Okay. I'm not sure why, but this is something that if we can see from more political perspective, okay, in many countries, especially in the election year, politicians will likely play the issues that related to the race, if you realize it, okay, compared the issues on the gender. This is something that quite uncommon for many countries, okay. By just looking at the United States, how they play very well in terms of mobilizing the voters, okay, according to the race of that particular voters. Okay, how the whites, how the black, how the Hispanic, okay, give the votes. It is quite on the basis on the race line, and there is no or less question about the gender. Okay, so that's why there's a tendency for many researchers, when they do the research on gender and race, they give more emphasis on the race compared to the gender. That's one particular issue that I think should be tackled with more like a balanced perspective on gender and also the other factors such as the race. And also, okay, they simply, state about the gender, the girls and the boys, but they do not provide, okay, what does it mean, okay, by this particular gender issues. They simply know, okay, how many girls, how many boys, but there is no answer. There is no further questions on how this gender impact the finding of their study. Okay, I think it is also quite common, especially in Malaysia. Okay, when the student do the research, they like to collect the demographics. Okay, especially the gender, the girls, the boys, and so on. Okay, but they did not really take into account how this gender give the effect to the finding of their studies. Okay, so I think that this is quite common, okay, for many countries. Okay, they just want to know about the demographics, especially the gender, the boys and the girls, without really tackling the issues on how this gender issue can provide the information on how it affects this research, the research findings. Okay, so I think that it is time for us to relook on how we can modify, on how we can have some innovations on how we do our research, okay, by using a more like a collective research method, okay. So we did not simply take the information about the gender. Why not? We have a further question, okay, especially on, knowing more about how the gender impact the findings of that particular research study, okay. So the third thing is that this is something that also uncommon for many research, is that many of them did not include parents. Okay, why parents matter? This is a question, especially if we look from more Asian perspective, because Asian parents have put a great influence to their children. But if you see, so many education research did not take into account the voices of the parents. Okay? Many of them focus either for the students themselves or the teachers. They neglect the parents who actually can provide also the education for the children. So that's why in our analysis, we found that the inclusion of parents as research participants is rather uncommon. Okay, so because I'm not sure, probably we see it something that, okay, parents have the different roles. Okay, they are just staying home and do their jobs at the offices without really taking care about the education of the children. I don't think it is a true perspective, especially when we were in pandemic of the COVID-19, where parents become the teachers at home. Okay, so that's the true story. Parents become the teachers, teaching the children when they were home, especially during the COVID-19. And I think that nowadays, parents are more likely to involve in the education of their children because they want to ensure that their children should be succeed in the education, especially in the physics, for instance. So only a few studies include parents as the research participants. And also it is reflected in many researches, I think in Malaysia and even in Indonesia, where parents are not really included as the research participants. So I think it is true for actually for many nations, not only for Malaysia. So that, what's the good about inclusion of parents, okay, for our study? Okay, one thing is that we know, especially for Asian parents, they really have a huge influence to their children at home, especially if they are checking the homework, okay, even providing the knowledge to that particular children. Me, myself also need to teach my children the mathematics or the science because, okay, some of the understanding cannot be obtained during the school. So the parents himself or herself, the mother and the father, need to teach the children at home after the school. So this is the real scenario in this particular era, especially the post-COVID-19 pandemic, where the parents become the teachers at home. If that's the case, I think that it is now the right time for us to include the parents as the research participants. This is how we advance the research area to the next level, which is the community level. It's a very wonderful opportunity for us to explore more about a new perspective in physics education by include the parents as our research participants. That's why I feel really proud because one of my former students, PhD student, did her research that include the parents of that particular children. Three parties, the teachers, the students, and also the parents to the students. It's a very wonderful research at the PhD level. Okay, I'm not sure if we have time, I can say or share more about that particular research, but I'm really happy because I know that this is something that actually we can do. But we also admit that we're not really familiar with the inclusion of parents in our research. This is something that I think we really know about it. But why not? Okay, we try to open our paradigm, open our mind, try to be more open to a new era where now parents has become the teachers for the students, for the children, for their children. Okay, so why not in the future we include more parents in our research? So this is my real experience teaching at one particular school in 2021. I noticed a quite striking difference between boys and girls when I teaching the physics. Okay, and based on my observation in that particular classroom, okay, I found that girls like to learn physics using more verbal explanation, memorization and using abstract languages by using a longer sentences. And even they can memorize a one-page essay without missing one word. So that's how wonderful girls can have a very strong memory in memorizing particular physics topic or physics understanding or the theories. However, that's the different case for the boys. They like to learn physics using more laboratory work, more hands-on activities, more projects, okay? And they even really like to invent, such as inventing a tool like a pulley model, okay? So in my classroom, okay, there is more issues on the gender perspective compared to the racial perspective. When I made the analysis of the test results, okay, the difference in terms of the race is not something that very, very different. But when I look into the gender perspective, comparing girls and also the boys, regardless of their race, yes, it shows a clear difference where the girls perform better than the boys simply because the way we assess physics usually on the theories and concepts, not really about assessing the projects, assessing the lab work that we do with the students. So there is no wonder why in many cases, okay, even though we have a greater number of boys in physics, but where they did not get sufficient hands-on activities, especially during the pandemic, we cannot do the hands-on. So it's really give the impact for these particular boys because what they really like to do is actually doing the lab work during the projects. They did not like to learn like the girls who really like to learn using the memorization, the explanations, and also the abstract language. So that's how I think the real scenario at the particular school when I teach this particular student groups. So that's the way forward. Collaborative efforts, the community, and the collective method. The 3 COs that I can simply simplify it. So I think this is the right time for us to work together. The multiple parties doing together for a common goal, which is tackling inequity in physics education. Now could be the right time for us to work together, means academics, students, and researchers, the teachers. We work together. It means that the way we do research should be something that a more innovative way. No longer we work in silo, not for the teachers, but it should be that doing the research with the teachers. Second one, I'm sorry, because I think I need to have some, extra water, right? As I discussed to you, the good about including the parents as the research participants. This is something that's still uncommon for many studies. So why not? After this, we consider including the parents as the research participants, especially if we do this kind of research in equity and social justice in physics education. And also, we can diversify and use the collective research method, whereby we can use multiple way of doing a data collection. We're not just doing the survey, we can also have a kind of interviewing, make the observation of the teaching and learning, analyzing the data. So it becomes a rich and also meaningful insights that can be generated for this particular equity issues. So it is more like what we call the mixed method research methodology, right? Mixed method, where it can provide us with enriched data, more holistic way of seeing our data, and more like we have a better understanding about the real scenario of the issues of equity and justice in science education or physics education in specific. And also, I think that's how we should do in the future. Okay, through collaboration, academic researchers can directly influence the school teachers, but at the same time, the school teachers can clearly show the real scenario of equity in actual setting. Means they need to have a regular meeting discussing the real issues, what happened in the school actually. Okay, and that's, I think, the best to do is for the teachers, he or herself, to make the story about the real scenario, the real problem located at a particular school, and how it can be assisted, it can be helped by the research from the university on how to tackle that particular issues. That's, I think, the best way to do to tackle the issues about equity and social justice in particular school locations. Then I think that that's how we can transform our education, okay, and not just maintaining the status quo, okay, because we think that we should think that in the future we should increase our collaboration, the university and also the school plus the parents itself, okay. And I think that for nowadays, okay, from today onwards, whenever we do this kind of equity and social justice issues research, we should consider including again the parents as one of the participants for us to understand better about the scenario of the children learning at home, for instance. And that's why with the use of such as the notion of FOK, the funds of knowledge, okay, it can give us some guides on how we can move further with this kind of new type of research, which is more like at the community level, not just for the education at school or even at the university, but we also create the implication, we create the impact, a greater impact for the community themselves. Okay, so I would like to thank all of these people who really helped me providing the inputs for my keynote presentations today. Okay, especially for my former PhD student, Dr. Izzah Mardiah. She's the one who became my first PhD student, studied about equity and social justice in physics education. I am really proud with her work. Okay, it's already get published in the reputable journal at the international level. Okay, and also she helped me to complete the writing on gender equity that I just showed to you just now. And also to my Professor Baska Upadi at my alma mater, University of Minnesota, United States. He's the one who actually exposed to me with the issues of equity and social justice in science education. To Professor Lilia Halim from University Kebangsaan Malaysia. She's my academic mentor who really helped me with writing and also articulating ideas on equity and justice in science education. And also to my my big boss, UTM rector, the Vice Chancellor, Professor Ahmad Fauzi. He's the one who really encouraged me to go further with my career progression. So with that, thank you very much for your listening to my keynote speech. Again, I'm sorry if there is some loopholes or any weaknesses or limitations for my presentations today, okay, because I was just informed to become the keynote speaker yesterday to replace one particular keynote who cannot make it today. So again, okay, I hope you enjoy my session. And if you want to ask me questions, yes, you are really welcome to do that. So that I end my speech. Wassalamualaikum warahmatullahi wabarakatuh. And thank you again for listening to my kind of lecture or speech of the keynote. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Benjamin. What's very interesting, a gender issue is something that we already knew, but it seems like we pay not much attention yet. So we face things like a gender stereotype that affected by our cultural things that I think it have a potential to be a reset in the future if we want to look more about that. So we still have a very short time for a Q&A part for this session. So if there is a question for the two presenters that already presented a very awesome presentation today, please just say your question or just type your question on the chat room in our Zoom. Is there any question here? Yes, Dr. Oka Saputra, please.
Oka Saputra from Universitas Negeri Surabaya. I have a question for Professor Miraj. My question is, in your experience, what are the most significant challenge in integrating educational robotics into traditional science classrooms, and how can they be overcome?
Okay, thank you. So the question for Professor Mirak Aiden, so how we can implement the educational robotics to the traditional science classroom. Could you respond to the question, Professor Aiden? Professor Aiden, can you hear us?
Okay, it's okay now.
Yes.
Okay, thank you for your question. Yes, it's very easy to implement educational robotics in traditional settings. Also, we made this implementation in the state schools in our country. Actually, first of all, we need to train teachers. If we achieve this, we achieve training teachers. We can integrate educational robotics into traditional settings, and we need educational robotics kits. You know, we can use some robotics kits such as Lego robotics, Arduino robotics, and so on. Arduino robotics can be used especially for traditional settings, but first of all, we need to train teachers, and then it's really easy to implement this technology into traditional settings. But we have to understand the implementation models. How can we implement this technology into the classroom, into the curriculums? We need to understand it, but it's really easy to implement it. You can see some details on our papers, which we published on reputable journals, which I show you on the presentation.
Does that answer the question, Dr. Oka Sabut? Okay. I think your answer is already very clear. Professor Aidens, is there any question? We still have a time. Yes, please.
Hello, good. Hello, can hear my voice?
Yeah, from Dr. Evi Sweba.
Okay, I'm Evi Soaiba from Universitas Negeri Surabaya, Indonesia. I want to ask about the gender equality to Professor Hadi Bunyamin. We know that now is about the gender equality is very famous subject in our education. And what are the main barriers to achieving gender equality in physics, and the strategies can be implemented to address this challenge effectively? Because in our department, female and male is similar, like 50%, 50%, but maybe in other country or other subject, there is still, we can see the difference between male and female. Thank you.
That's very interesting. Could you please answer the question, Dr. Benjamin?
Okay, thank you for that particular
Yeah.
question. Okay, can you hear me? Okay, I hope you can hear. Okay, so to answer that question, okay, the reason why there could be imbalance, okay, in some places, it could not be the all places around the world. Okay, it could be applicable to certain places, especially when we know that the enrollment of in science streams around the globe are declining. Okay, this is something true for many countries, okay, including Malaysia and even in the United States and also in the UK, if I'm not mistaken. Okay, the decline of enrollment in science streams that gave impact not just for physical sciences but also the life sciences. But the problem is that if you are familiar with the phenomena of the lost boys, okay, the lost boys means that it doesn't mean that boys are not is not sufficient in number or so what. It is not the issue. The issue is that, okay, whenever a boy completed their study at the school level, after that, many of them decided to not continue their study at the higher education level. Okay, and why this has happened is that one thing we know very well, the way we make the assessment of learning or for learning in science or physics in particular, okay, usually we really evaluate the students based on the understanding on the theories and also the concepts. It's quite rare for us to evaluate or assess the students for the projects, for any kind of hands-on activities, for any kind of lab works that did not really have or did not given sufficient weightage in the assessment. Okay, I think that many of assessment today is still on the theory-oriented assessment, and that's not a good balance for given to the practical aspect of the physics. Okay, even though in my experience and even if you learn more about the gender preference, boys are likely to learn if they can do more a kind of hands-on activities and the projects rather than memorizing one whole page of essay, okay, as shown by one of the student in my classroom. It's a very wonderful way of memorizing, okay, a very strong memory, but there is no boys who can do that, okay? So I think the real issue today is really about how we give a good weightage of assessment in terms of the practical dimensions of the physics education. So by doing that, by solving that particular issues, giving a balance of theory and practice and the assessment of the students' learning in these two dimensions, the theories and also the practice, it could be a way for us to tackle the issues about gender equity in physics education. Okay, so this could be a reason why boys have no inclination to further studies at the higher education level. Maybe for certain countries, not all. It's really happened in Malaysia. Okay, many of boys will go for the technical and vocational courses after completing their studies at the school level. They have no interest to involve in science streams or any kind of science, physical sciences, or even life sciences. Okay, they really like to do the skill-based jobs after completing their study. So I think it is about how the boys learn. Okay, it's more like the hands-on way instead of more like the minds-on or the theory-based. So it could be one of the reason and could be one of the answer, even though I think that, yes, we can explore more answers, on why and how to tackle these issues from gender perspective. But today, I think it is the right time for us to revise the way we assess our students, not totally on the theory part, but must also include the dimensions on the practical aspect of physics education. I hope it will or it be able to answer your question.
Yes.
Okay,
It's
thank
already
you.
answered the question, isn't it? So it depends on the area and also depends on the context. Yes, we already have a much more big number of female students, isn't it? So there is a last question, I think, because we have a very limited time. I think it's a general question from our first presenters, from Professor Hiroshi Kawarada, because it's that really happened in Indonesia. So the question is, are students who wants to study physics increasing or decreasing in your country? Because in Japan, decreasing. And for the information, in Indonesia also seems to be decreasing. Professor Aiden, maybe, how about in Turkey?
Yes, we have some problems about number of physics students. Students don't like physics and don't prefer to studying in physics. Yes, there is a decline in number of students. But actually, I'm a science educator. I mean that I focused on middle grade students, not for high school students. So maybe we need to ask this question to studying physics education in Turkey. But according to my experiences, yes, there is a decline in number of physics students in Turkey also.
How about in Malaysia, Dr. Benjamin? Thank you, Professor Aiden. How about in Malaysia?
You are
Yes.
welcome.
The same phenomena, the decline in the interest and the enrollment in physical sciences, okay? Because as I mentioned to you, okay, many boys, especially, they started to choose to take the skill-based courses and programs, especially technical and vocational education and training, because they feel that that's how the system will well appreciate the skills and the capabilities of themselves in order for them to move forward with the job security, for instance. So it's really about how they see how good is that particular programs, either science or the technical vocational, that can well appreciate their capabilities. And I think that one reason why we cannot can get the sufficient number of the students, especially the boys, okay, for the science stream nowadays, is that they think the science is something that more on the theoretical part, okay? But less emphasis was given to the hands-on dimensions, the projects, the lab work, okay? So that's why I think the real issue today of education is really about the assessment, how we can reform our assessment so that it can well appreciate the capabilities of the students, either it is boy or the girl, and have a balance on the theory and also the practical dimensions of the physics education. Yeah.
Thank you, Dr. Benjamin. Oops, I think the time is already past. So personally, I would like to have longer discussions, but unfortunately, the time is very limited. So what amazing presentation that we have today. The development of technology nowadays will affect our educational culture and system. How we communicate and teach today has changed since COVID-19. Implementing advanced technology in school is unavoidable. Both presenter already highlights the importance of technology in supporting science and physics education. However, we should also consider the accessibility, justice, and equity, particularly in areas of Indonesia, where technology implementation could be very challenging. Seems like we still have a lot of work to do to ensure it works for a better future. Many thanks to our presenters today, Professor Dr. Mirak Aidin and the Associate Professor Dr. Muhammad Abdul Hati Bunyamin. Thank you for the ISoPA 2024 committee, all the member of Physics Department, the State University of Surabaya, all the audience. I'm Mita Anggariani. See you in the next occasions. Back to the master ceremony. Thank you.
Okay, thank you, Mrs. Mita, Professor Aided, and Dr. Bunyamin, bringing us to a wonderful discussion. Has been also to the session. Symbol of gratitude, committee provides a token of appreciation for Professor Den and Dr. Bunyamin. Therefore, please, Dr. Muhammad Satriawan, to provide the token of appreciation for Professor Aiden and Dr. Bunyamin.
Thank you.
Okay, thank you so much, Professor Mirak Aidin, for your knowledge and presentation. It was great. And Dr. Hadi Bunyamin, thank you so much for your presentation, and your material is very, very great. So this is certificate for our appreciation for you, Mr. Thank you so much. Okay, this is a second certificate for Associate Professor Muhammad Abdul Hadi Bunyamin, PhD. Thank you so much for your attend in here in our program, International Seminar on Physics and its Application 2024. Thank you so much, sir.
Well, this is the end of the second plenary sessions. Thank you for your participation. We will take a break for 1 hour and be right back for parallel session at 13:30 Western Indonesian times. After the parallel session, we come to the end of today's conference. On behalf of the International Seminar on Physics and its Application, ISoPA 2024 Committee, we would like to say thank you for your participation today. If you have a problem, you can directly contact the committee of ISoPA 20 and 24. See you on the next stage. I'm Farah Ashika. Thank you and enjoy your parallel session.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Kampus Unesa Ketintang, Surabaya. There are 2 study programs for undergraduate students in our Physics Department, the undergraduate program of Physics and the undergraduate program of Physics Education. This is the profile of the undergraduate program of Physics.
Hello, I am Munasir, the chief of the undergraduate program of Physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teachers reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of Physics. The undergraduate program of Physics aims to strengthen physics educational that has already been established for years. In line with the needs of society and professional work field, this study program also experience dynamic development. This study program from 3 area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating earth disaster, tsunami and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these 3 clusters, we want to prepare our graduates excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, instrumentation and optic, material and characterization. Inshallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the Physics Department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between two surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match the indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment. Different to basic physics laboratory, in this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the two photogates. The length between the two photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aim to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual trace oscilloscope, students can examine resonancy frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Gamris features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, shrink pump and shrink drum collector, camera and LCD monitor, silica gel, humidity, and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, hitting the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who want to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some selling points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake. Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Kampus Unesa Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department: the undergraduate program of Physics and the undergraduate program of Physics Education. This is the profile of the undergraduate program of Physics.
Hello, I am Munasir, the chief of the undergraduate program of Physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of Physics. The undergraduate program of Physics aims to strengthen physics educational that has already been established for years. In line with the needs of society and professional work field, this study program also experience dynamic development. The study program from three area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating earth disaster, tsunami, and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these three clusters, we want to prepare our graduates excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optic, Material and Characterization. Inshallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the Physics Department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between two surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment. Different to basic physics laboratory, in this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the two photogates. The length between the two photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aim to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Cambridge features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, shrink pump and shrink drum collector, camera and LCD monitor, silica gel, humidity, and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, heating the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who want to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some selling points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake. Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Kampus Unesa, Ketintang, Surabaya. There are 2 study programs for undergraduate students in our Physics Department, the Undergraduate Program of Physics and the Undergraduate Program of Physics Education. This is the profile of the Undergraduate Program of Physics.
Hello, I am Munasir, the chief of the undergraduate program of physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program. We include the undergraduate program of physics. The undergraduate program of physics aims to strengthen physics educational that has already been established for years. In line with the need of society and professional work field, this study program also experienced dynamic development. The study program from 3 area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating disaster, tsunami, and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these 3 clusters, we want to prepare our graduates excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optics, Material and Characterization. Insyaallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the Physics Department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of these topics is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between 2 surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match the indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment, different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the 2 photogates. The length between the 2 photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aim to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual-trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Cambridge features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, string pump and string drum collector, camera and LCD monitor, silica gel, humidity and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, heating the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students. as well as postgraduate students who wants to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some selling points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake. Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Campus UNESA Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department, the undergraduate program of Physics and the undergraduate program of Physics Education. This is the profile of the undergraduate program of Physics.
Hello, I am Munasir, the chief of the undergraduate program of Physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of Physics. The undergraduate program of Physics aims to strengthen physics educational that has already been established for years. In line with the needs of society and professional work field, this study program also experienced dynamic development. This study program from three area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating earth disaster, tsunami and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these three clusters, we want to prepare our graduate excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optics, Material and Characterization. Insyaallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the physics department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between two surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment, different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the two photogates. The length between the two photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aim to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Gamris features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, shrink pump and shrink drum collector, camera and LCD monitor, silica gel, humidity, and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, heating the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who want to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some salient points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake. Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics
I'm very sorry, Bapak Dwihanto. We suddenly moved to the main room. We left the room A and we moved to the main room, and we can hear some minutes of your frequency because your mic also unmute, also mute. I'm very sorry.
May I continue my presentation? Okay, sorry.
I'm very sorry.
Okay.
I'm very sorry. No. If I'm not mistaken, from the measurement of ITOF, in with straight line regression, the last PowerPoint that you have said.
This one?
Maybe we can continue.
This one, Bu Ratna?
I still can see the PowerPoint. I can see your PowerPoint. Have you already shared the PowerPoint?
Okay. Okay, I will share my presentation now. You can see my PowerPoint?
After this one, after this PowerPoint.
Okay.
After this, I'm very sorry.
Okay. No problem.
We are suddenly moved to the main room and left the room A.
Okay. Let's continue my presentation. Compromise that issue, we use to modulation frequency switching between 2 megahertz for low frequency and 10 megahertz for high modulation frequency. The illustration can be seen on the left side. Therefore, in this situation, there are two pass delays, this one and this one. To define a distance, we propose a rule base as shown in this table. Additional information, you can read our paper, which was published in IEEE Transaction Instrument on Instrumentation and Measurement last year. Please have a look at this figure. Interestingly, there are no longer ambiguity ring. When we measured a target until 56 meters after applied our proposed algorithm. Using the equation from of LiDAR, as previously mentioned, the system can calculate it easily. The measured distance as shown in this graph. Compared to actual distance, this one is x-axis and y-axis for measured distance. The measured distance by proposed algorithm is good and linear. Then we also explore the height of LiDAR to measure various kind of targets. As we know, in real life application, an object as a target in the LiDAR system has various reflectances from very low up to very high. Therefore, we try to use aluminum foil AF for high reflectance and HIPS, high impact polystyrene for low reflectance. We can see in the left graph that the strength signal is also different. AF is higher than HIPS, and also maximum ring, the maximum ring is different. 56 meter for aluminum foil for black dot, and HIPS has only 33 meter for HIPS. The detailed explanation will be presented by our colleague, Mr. Hari Pratomo, who is also present in this conference, maybe after me, but different room, room B. Next, we still on the LiDAR rangefinder, that is FMCW LiDAR. Besides of LiDAR, we also explore the FMCW LiDAR. FMCW LiDAR employs a continuous wave laser whose frequency is modulated over time. The advantage of FMCW LiDAR is such as simultaneous between distance and velocity, and longer ambiguity range order in kilometer, and also enhancing resolution, signal to noise ratio, and dynamic range. Unlike of LiDAR, FMCW LiDAR defining a distance is calculated by analyzing the bit frequency, as shown in this illustration. Here, the result of the experiment in our lab, which was published in AIP conference proceeding in this year. Even though in this experiment employed by using a fiber optic to confirm a longer distance, we can see relation between length or distance of target and bit frequency is linear, more than 300 meter. This confirms that FMCW LiDAR can extend the ambiguity range if compared to the ITOF LiDAR. Now we are going to the part 3, 3D LiDAR. Previously, we have discussed the LiDAR rangefinder. That LiDAR just emit to one point or one direction. The question is, how does the LiDAR see the surrounding and its environment? Right, it needs 3D LiDAR to construct a detailed 3D structure of the environment. Regarding 3D LiDAR technology, there are some methods on how to make 3D LiDAR. For example, using motor for the simple one in 3D LiDAR, that is a rotational LiDAR, and then a beam scanner, and also meta surface beam, and so on. And here is a rotational 3D LiDAR we have developed in our lab. In this case, we use a commercial LiDAR, then we modify it in order to scan 3D objects. And we also develop a program to reconstruct a 3D object. Now, please watch this video. We use two people as object. LiDAR is scanning continuously. We can see at this program, we can observe the reconstruction of the object in real time. We can see two objects clearly. This one for left person and this one for the right person. This is an example 3D LiDAR for autonomous system. We can see a person in this display. This is the LiDAR, the position of LiDAR. This is the program. When the person is near the LiDAR, the indicator lamp changes from green to red. This is red because near from LiDAR. Now we can see the one person in the right side. Now 2%. Now the indicator lamp changes to red because it's very near to LiDAR. Now green, non-brake indicator. And this is implemented to control autonomous vehicle because it's very near 4 meters. So the vehicle stop. Another one, we also developed a 3D LiDAR which employs a beam galvano scanner. Compared to rotational 3D LiDAR, as previous mentioned, using a beam galvano scanner is more compact and lightweight due to just the laser beam being reflected by very quickly by a mirror. For example, here's the beam scanning using galvano scanner. This is galvano scanner, and this one the laser beam. This is the light is deflected by mirror from galvano scanner. Next, going to the challenges and trends in LiDAR. LiDAR technology faces several challenges that can impact its performance and adoption across various applications. Here is some of the key challenges. First, range, including maximum range and resolution. Second, safety, including eye or skin safety issues. Three, cost, of course, optoelectronic component now still high. For reliability, regarding environmental influences. Five, size. Now with the development of nanotechnology, LiDAR can be designed as a compact and more smaller. Regarding the application, many kind of applications use LiDAR technology such as automotive, topography, bathymetry tomography, and so on. And in the last part, we are going to give some information from BRIN. Now we are open for postdoctoral researcher, visiting researcher, and also visiting professors. We also can hire research assistant and scholarship for students. For information, please visit our website at managementtalenta.bin.go.id. And also by research BRIN for the scholarship by BRIN. That's all my presentation. Thank you very much.
Thank you very much, Bapak Dwi Hanto, PhD, for the nice and full of full of informations. Okay, next we will continue to the Q&A questions. So please, if there are any questions for the participants and the presenters, you can raise your hand or write in the chat box. Okay, I would like to ask you, Bapak Dwi Hanto, I interested on 3D LiDAR.
Yes, right.
In your presentations. So the LiDAR will moving, continuously to some degree, following some degree, or how is the mechanism of the 3D LiDAR. The one with, as you mentioned, with the motor
Yes, right.
can rotate the LiDAR.
Okay, for 3D LiDAR, we have developed in my laboratory. We have two options for 3D LiDAR. First, by using motor, and the second one by using beam scanner, LiDAR, that is galvano scanner. The first one is rotational LiDAR. We use motor because this is very simple and low cost. In compromise to the 3D object, so we rotate the LiDAR in horizontal and also in vertical. From this mechanism, we can, for example, in this one, we can from maybe from upper or upper left horizontal, and then to right, upper right, and then down and to the left, so we can scan a view of the object. Just the principle of 3D LiDAR. And the second one, we use galvano scanner. Galvano scanner. The principle is different because in this method, we just move the laser beam by mirror. The thing of the horizontal degree maybe it's different. In this application, we have to hear from the application. For example, for autonomous vehicle, in autonomous vehicle, maybe we have to see by LiDAR in the front, maybe not ring in 36 degree, just only in 60 degree in horizontal and also 100 degree in vertical. So for this application, we have to see the requirement of the application. For example, in autonomous vehicle. This is my question. My answer. Any question more, Miss Buratna, right?
Endah.
Oh, Bu Endah, I'm sorry, Bu Endah.
Yeah, it's okay. Thank you very much for the brief explanations. And maybe any other questions? One more questions? Or enough? Okay, I think we have a limited time. I'm very sorry, Bapak Dwi Hanto. It is a very nice
You're
presentations. And thank you very much for the informations about the opportunity to join in your laboratory. Dear students, maybe you interested, so you can contact Bapak Dwi Hanto, PhD. Thank you very much once again, Bapak Dwi Hanto, PhD. And give applause to Bapak Dwi Hanto, PhD. Okay, room A actually suddenly moved to the main room. So I hope all the presenters in room A already in the main room, so we can continue for the presentation of parallel session. In this parallel sessions, we noticed that all presenter already sent a video of presentations. So we will We will share the video presentation with the help of the operator. Three video first of this is Bapak or Ibu Minar Titis Santoso. Bapak. The presenter of Minar Titis Santoso already in room A. Bapak Minar. Bapak Hendra Saputra Pratama. Masuk ke room. Mana? Tolong dibantu. Ini enaknya yang room E balik ke room E atau tetap di main room? Okay, I'm sorry. Can you hear my voice for the main room or room A? Hello? Participants and presenters in room A or main room, can you hear my voice?
Yes, yes. I heard
Okay, thank you very
your
much.
voice. For
Okay,
the
thank you
next,
very much.
we will stay in main room or in room A? Or
Please stay in main room.
main room,
Okay.
yeah. Okay, okay. Thank you.
Please stay in main room. Okay,
Okay.
thank you very much.
Okay.
Okay, we will share the video, but please, the presenter, Minar Titi Santoso and Bapak Hendra Saputra Pratama. Bapak Hendra Saputra Pratama have two papers, so we will share the video, both of them. And after that, there will be a question and answer. So the presenter, Minar Titi Santoso, already in this room. Minar Titi Santoso. Okay, if there is we will continue to the video presentation of Bapak Hendra Saputra Pratama. Mbak Vivi, operator, please share the video of presentations. Bapak Hendra ya.
I'm sorry for the committee. Uh, for the efficiency of the time, please the first opportunity for presenter will ready or
For presentation directly.
yes,
Okay.
directly.
I offer to this parallel
Directly.
session of room A. I know you already sent the video, but we have trouble to share the video. Maybe you
Okay, yeah,
can
directly presentation.
you can have direct presentations. Anyone ready in this room A?
I am ready.
Bapak Bustami?
Yeah. 7X7 number.
Okay.
7X7 number.
Sorry,
PowerPoint.
sorry.
Yes.
Please take the schedule. There is the G form that we already fill that, and please check again who is the already in choose for the direct presentation, and I hope that that relate with the list in the room A
Okay.
presentation.
In room A presentations, the
Okay.
data I get is
Okay.
all have video presentations.
Okay.
Yes, but we are already choose which one the direct presentation or by video.
Okay. By video okay, direct presentation
Yes,
is okay.
because I think we are upload two kinds
Yes.
of file.
Yes, I have
Okay.
send my video or my PPT.
Okay, so I will call from the first presenter, Minartiti Santoso. Are you ready for the direct presentations? Please give a response. Minartiti Santoso.
Yes, I'm ready for video.
For video. Okay, then I move to Bapak Hendra Saputra. Are you ready for direct presentations?
Okay, Dimis.
Okay. I would like to share the PPT. Or are you, can you share your own PPT? Bapak Hendra, can you share your own PowerPoint?
I try miss I want to share my video that I sent to Gmail. Where is?
Halo. Apa tak? Tuh. PPT. Wes ana
Is my screen has appear in your screen, Miss?
Yes, we can see your PowerPoint. Please start the presentations.
Okay, I will start with my video.
Thank you for being here. My name is Hendra. Today I will present the results of my research with title Continued Development of Let and Forging Book Instructions as practical guidelines in the Department of Mechanical Engineering. The researchers is me, Endra Saputra Pratama, and my friend Gitu Sidarto. This presentation will be divided into 4 parts. That is for first introduction, second is methods, result and discussion, and the fourth conclusion and suggestion. Okay, for introduction, in the learning in the learning process, it is important to align goals in order to achieve optimal learning conditions. The general aims of this research is to obtain an overview of the continual development of plate and forging work instruction as a guide in the plate and forging practicum course at the Department of Mechanical Engineering, State University of Surabaya. Meanwhile, specifically, this research aims to describe the process and quality of further development of plate and forging work instruction used by students and educators at the Mechanical Engineering Department at University of Surabaya. This research still uses the development method. The development model used in a procedural model. We are the specific model that says the steps that must be taken to produce a product. The data was obtained from both instruction literature source in the practical plate and forging course, which was used. The data collection technique used a questionnaire method with a sample of students who were at or had taken the practical plate and forging course. Overall, the average score of students who used the development of work instruction teaching material was 3.11 out of a score rank of 4, which is the very feasible and usable category. In the method, in this research method was used namely the research and development method by both WR and GAL MD. This is the figure 1 for flowchart of the research result and discussion. So the work instruction developed in this research consists of 3 core materials, namely for the first rectangular angle funnel, for the second rectangular tube funnel, and for the third trapezoidal funnel. After the work instruction has been completed, they are validated by 2 validators who are experts in their field, namely the rector who teaches the course. This work instruction assessment contains 3 aspects of validation, namely aspect of appearance, presentation of material, and usefulness of work instruction. The assessment of these 3 aspects is based on a Likert scale with an explanation for each value category, namely 1, strongly agree, 2, disagree, 3, agree, 4, strongly agree. In sampling, a data collection technique was carried out using a closed data questionnaire that each participants only put a checklist on the answer sheet that had been prepared. This closed questionnaire instrument was given to expert lecturers or validators and practical students who were participating in plate and forging practical activities, and the research subjects were top 2 students. And for the conclusion and suggestion, the use of work instruction in the teaching and learning process of students can actually be a learning activity that practitioners can complete independently. In the teaching and learning process, students apply work instruction with the aim of achieving things among others. 1, stimulating motivation and enthusiasm for practical learning. 2, anticipating limited space, time, and sensory abilities for practitioners and lectures or instructors. 3. Exploring practical abilities in real interaction with the environment and other learning resources. 4. Providing opportunities for practitioners to be independent based on interests and abilities. 5. To know how to make an object according to practical procedures. 6. To increase skills in carrying out a procedure. 7. To know the basic guidelines for carrying out a procedure. Suggestion. Further development of this work instruction is still within the scope of the Department of Mechanical Engineering, Surabaya State University. So further research and development needs to be carried out on a wider scale. The second, in this research, there is still no validation aspect from the design team. Therefore, this work instruction can be further developed by requesting validation from a team of experts in the design fields. Third, in this research, 75% of the job sheet drawing is still used to the drawings. In the future, job sheet drawings can be developed to use 3D drawings to make it easier for students to illustrate finished drawing with objects. Thank you for hearing my presentation.
Please continue to the next video. You have two video. The other one is with the ID paper 6 to 9. Design of an electroplating tool based on the automatic timer for plating metal with chromium.
Okay. Wait, Miss.
Hello, good overall everything.
I'm sorry, I can hear the voice of the video.
Pardon me, Miss. Why my video this not appear in your screen or what?
Your video appear in my screen, but we can hear the voice of the video. We can hear the voice of the video.
Okay, I will continue the
Now we can hear, please.
Okay, I will continue my
Okay,
video.
please.
Chromium. The researcher is Mei Langgeng. May friend Hendra Saputra Pratama and my partner Kustiono Lamiran Sodhiro Neryo. The next presentation will be the person be my partner Kustiono.
Introduction. Electroplating is a surface coating which causes the layer to become dense, sticky, and homogeneous in the form of metal or a mixture that stick to the surface using electric current. This layer is useful as a protective, decorative, and improved surface characteristic. The surface format is either a conductor such as metal or a non-conductor such as plastic. The central part of the electroplating journey is the electrolyte cell or electroplating unit. In an electrolytic cell, a bed of current is passed. Drop will contain the electrolyte, anode and cathode. So far, to cut metal only using a manual timer. After dipping the workpiece in a small cup, it is then left to soak for approximately 60 minutes. If there are dozens of students in the practicum, the waiting time becomes less effective and inefficient and result in the practicum being postponed to the following week. If this happens continuously, then the learning process will not run, will result in the planned competency not being achieved. Method. The method for this research is research and development method. The research and development R&D research procedure began with the research, pre-research, second the research stage. For more detail, it is found in the flow chart of the research design as follows. Result and discussion. This timer control-based electroplating tool is used for the chrome plating process for practical material in the metal plating laboratory using a 50-watt rod heater and aerator. This timer control-based electroplating tool consists of a socket as a power source. As way to turn on off the power flow, a timer as a control of the on-off time regulate for the heater and this tool. ESU power supply unit as a power supply, a step-down module to increase or decrease the adapter voltage, an aerator to decompose the electrolyte solution, and a heater to assess the chrome plating process. This electroplating tool is used in the chrome plating process for small or medium-sized workpiece such as coin, small tool, or screwdriver plier, nails, recycle spoke, nut, bolt. The material for making this electroplating tool are made from an iron frame with a thickness of 0.4 millimeter and a plastic tube measuring 360 into 130 millimeter with a capacity of 15 liter, which makes the body and frame of the electroplating tool strong, practical, and of good aesthetic value. This electroplating tool is capable of coating a workpiece in approximately 60 to 100 minutes at a temperature of 40 to 80 degrees Celsius. This electroplating tool is suitable for use in practical workshop and business workshop to improve the quality of coating result at a relatively affordable cost without sacrificing quality. Here is the realization of the original embodiment of the electroplating tool. Conclusion and conclusion. The conclusion is that the design of electroplating equipment has provided a solution to existing problems, namely the availability of an automatic timer which function to certain time and have a larger box capacity so that practicum time can be made more efficient. Several methods such as the frame, electricity, plating tank, heater, aerator, and cathode hanger have function on a small scale. Namely, for practical need, within the future will be made for a wider scale. The process before starting electroplating is very complex and can affect the result, such as the smoothing process or sandpaper which must be smooth and requires precision. An unclean cathode hanger will inhibit the incoming current, making the specimen not evenly cut. Temperatures that are too hot can cause the workpiece become burned. Voltage that is too hot can cause the specimen to become spotty, and the quality of the nickel liquid is not clean, or the liquid is lumped, so that the specimen is not cut properly, so it looks dirty. The manufacture of this electroplating tool is still within the scope of the Department of Mechanical Engineering, Surabaya State University. The further research and development needs to be carried out on a wider scale. Thank you.
Okay. I'm very sorry, dear presenters. Hello? Okay. I'm very sorry, dear presenters, because I think I'm in and out from the room because of the connections. And after the two presentations of Bapak Indra Saputra, is there any questions from the participants or other presenters? Any questions? Okay, I have one questions. What is the difficulties you found when you design these electroplating tools?
Okay, I try to answer your question. For the first, the first is the place, because we have limited space in our faculty, and the second is the time, because we have to efficiently the time, because we work after the work, outside the work hour. I think that is the more difficulties from us. Thank you, Miss.
Thank you
Enda.
very much. Yeah, thank you very much for the answers. Okay, I think it's enough. We will continue to the next presenters. Here we have Bapak Suhadi and Ibu Putu Budi Yasmini. Would you like to share your video? First, Bapak Suhadi. Bapak Suhadi in this room? Okay. Bapak Suwadi from Universitas Negeri Surabaya. Okay, please start your video. Bapak Suwadi, can you hear my voice?
Yeah,
Okay.
ma'am, because my video at any trouble, I am live presentation.
Okay, please.
Good afternoon, everyone. First of all, let me thank you all for coming here today. Let me introduce myself. I am Roni Tumena from Surabaya State University. Today, I am here to present to you with title Friction Welding Mechanic Design. As you can see to screen of our title today, my presentation is in few parts. First title itu Precision Welding Mechanic Design. First author Suhadi Ko Roni Tuhumena. Introduction. Development of welding is related to technology which is also developing. The welding that is currently developing is friction welding and also friction stir welding. The use of friction welding is to combine two shafts using a friction welding mechanic, and currently there is a lot of research from lecturer and student about friction welding with publication and national and international journal. Research objective: one, design and build and friction welding mechanic that is useful for reason by lecturer and student at the Department of Mechanic Engineering, Surabaya State University. Two, can be used as practicum for mechanical engineering student in getting to new various welding method. Method use reason is experimental analysis research. Diagram below flow chart. Begin start study literature, drawing and design planning. Planning material analysis, hydraulic system, production process, assembling. Next, mechanic test. If no, repair, come back planning, material analysis, hydraulic system, production process, assembling, mechanic test. If yes, conclusion, finishing. Result has actual drawing, 3 dimension below picture. Untuk for actual design below picture, design to building a pressing tool with hydraulic mechanics as a replacement for the tailstock. This tool is placed in the position where this tailstock is placed on the lead system hydraulic. System hydraulic use number 1 hydraulic cylinder hydraulic, number 2 steering valve, number 3 hydraulic pump, Number 4, flexible hose. Number 5, hydraulic tank. Number 6, electric motor. Number 7, fitting. Testing process. 1, setting the hydraulic pressing tool with the lead chuck. In the setting, 2 separate pieces of iron are used which are gripped in the chuck of the hydraulic press and grip in the lead chuck with set the center, normally parallel to the 2 sharp angle with the distance between the specimen that will be tested for welding. 2, the welding process is to turn on the lead with the desired rotation, namely 1,800 RPM, and the position of the chuck on the pressing tool is not rotation. Attack it the surface of the boat and the ends of the shaft and then move the valve lever slowly forward to create frictional press which will result in surface heating of the 2 specimen by applying pressure cooling tempering pressure, so the connection between the 2 specimen occurs. After the connection occurs, wait for a few seconds and let up carry out.
Ini bukan laptop saya. Ini juga keluar masuk.
Break through off the lead and remove the welding specimen. The next Russell version welding. Then thank you for listening my presentation.
Okay, thank you very much. And we will continue with Ibu Luh Putri Budi Yasmini from Universitas Pendidikan Ganesha. Please, Ibu Luh Putri Budi Yasmini, share your presentations or your video. Ini speakernya tadi saya mute, speakernya dan sini. Ini saya mau Ibu Luh Putri Budi, can you hear my voice? Hello? Ibu Luh Putri Budi, are you hear my voice? Once again, Ibu Luh Putri Budi. Hello? Ibu Luh Putri Budi, can you hear my voice?
What?
I'm sorry, Bu Endah. I'm sorry. Can I share but without on camera?
Okay. Wait, we already shared the video.
Okay.
Can you see the video?
No, I can see that. I can see that.
Okay. You may share the video, your video or direct presentations.
Okay, I will direct presentation.
Okay, please. Sudah di-answer.
Okay, Ibu, can you see that presentation? Can you see the presentation, Ibu?
Not yet.
Okay, wait a minute. Already, Ibu?
Okay, already. Please start your presentations.
Okay, thank you. I'm sorry, I will off the camera because there is a connection. There is a problem in the connection. Good afternoon. Thank you for the chance that given to me. Now I would like to present about the title of this studies, rigid body motion, DNA factor for the analyzed by the Navigator block method. Okay, physics that is rigid body motion. Rigid body motion that related with two kinds of motion, rotation and translation motion. We know that the rigid body system is between 2 points in the rigid body motion. There this motion, screw motion is like combination of the random motion that join already, while the rotation there is rotation motion. Okay, based on that, by the definition, I'm sorry, I will continue that. Okay. Yeah. By the definition, rigid body transformation is the mapping from the Euclidean to the Euclidean. So this study is a theoretical study. This is about the literature study and visualization by the MATLAB. So by the definition, we find that the rigid body transformation is mapping from the Euclidean to the Euclidean, with the characterized by that Paris the length is preserved and the cross product of the two factor in Euclidean is preserved too.
Actually, we can see your PowerPoint.
Okay. Wait a minute, there is a problem in the connection, I think, in here because this is already in, and there's cloudy in here. Sorry. You can see the.
Not yet. We can see your presentations. Yes, already.
Okay, now we are continue to the rotation motion. By the rotation motion, based on this definition, for example, for the rotation motion, there is a metric transformation that represent the mapping like this equation. Okay. Okay. For this study, we analyze the kinematic of robot motion with 4 degrees of freedom, like the figure in one, whereas the system configuration is a pair of P and R. Whereas the P is the component of the position describing the translation motion, and the R is as a metric transformation, rotation metric transformation that represent the rotation motion. Okay, generally the metric transformation that we will analyze is like in equation 1, like that equation. Okay, but for the one component in that analysis in that equation 1, for example, the joint between Li joint to the Li minus 1 joint, we can analyze by equation 2 and we can get the equation 4. This is the literature study and analytical manually. Okay. Based from that, by the Denafit-Heppenberg method, we can write the coordinate configuration of the figure 1 and we can get this one. This is the link one. This is the frame S with the stay frame. And this is the n effector of the system. This is the n effector of the system. This is by this figure we can make the parameter that related with the Denafit-Heppenberg, which one the theta and the alpha is the parameter for the rotation motion, D and I is the related with the translation motion. So based on this configuration and the picture picture 1, we can write this parameter. After this one, we can analyze, we can get the equation of motion of the system that we study, and we get the equation 10. This is describing the equation of motion, the kinematic robot manipulator for 4 degree of freedom. Okay. For visualization of that equation, we are using the MATLAB. We choose one initial position like this one, and after that we arrange the different position, for related with the theta 1, theta 2, theta 3, theta 4 with the different angle. That sum of the sum of theta 1, theta 2, theta 3 and the same angle, and we get that all of these n effector of the system will be different. So I think that the n effector of position of the robot will depend on the combination of theta 2, theta 3, and theta 4. Okay, based on that, we can conclude that the equation of motion that describing the motion of the robot for DOF, like the picture in figure 1, we can get the equation 10 as the robot motion. And based on the analysis and visualization by MATLAB, we found that the configuration of angle rotation related with the different of the n effector of the system. That about my presentation. I will say thank you. Sorry for the trouble.
Thank you very much for the presentation, Ibu Luputi Budi. And now for the Q and answer session. Please, Bapak Ibu, if you have any questions for the two presenters, Bapak Suhadi and Ibu Luputi Budi. Okay, I have a question for Ibu Luputu Budi. I'm sorry, I don't get it. What is the meaning of the effector? Is it the positions that we input to the robot or something else?
An effector is the position of the last join of the robot.
So we input the positions.
Yes.
And then we see the effector, the last position. Is it the same with the position that we input at the first time?
No, that's different.
No.
So if the theta, theta 2, theta 3, theta 4, we choose the how much the angle of the rotation, so that if that have a different effect of an effector, the different position of the n effector. So n effector is the last hand. Okay, we can say that the last hand of the robot that related with the movement of the joint.
Okay, I know what you mean. Thank you very much for the explanations.
Thank you.
Any questions? Okay, for Bapak Suhadi, I have a questions. Friction welding machine design. I'm sorry because I am in and out of the room, so I can get all the presentations. So, what's the point in this research? Are you design the welding machine for frictions or reduce the frictions or fixing the frictions? I'm very sorry. Bapak Suhadi?
Friction welding, Indonesian pengelasan. Design friction welding for practicum and research lecture and student.
So you design the friction welding machine. You design the friction welding machine for the experiment of the students.
Yeah, technical machine university, faculty, technic university, state university, Surabaya State University. Or
Okay, thank you very much for the answer. Any more questions? Enough? Okay, thank you very much for Bapak Suhadi and Ibu Luputu Budi Yasmini for the presentations. And we can continue to the next presenter, Bapak Kriswanto and Bapak Bustomi.
Yes, I am ready.
Bapak Kriswanto. Okay. Bapak Kriswanto, please share your video, or maybe you want to conduct direct presentations. Oh, Bapak Bustomi or Bapak Kriswanto, answer me.
The share screen is sharing.
Okay, we can see the screen.
Okay, I start the video.
Okay.
Hello everyone, my name is Victor Nugraiswa Winarso. I give this water paper with title is Effect of Variation in the Offset Physics Derivative 1083 on Tensile Strength and Hardness. With all the author from Department of Mechanical Engineering, Universitas Negeri Semarang and Polytechnic Technology Negeri. The outline of this presentation is introduction, material and methods, result and discussion, and conclusion. Introduction. Aluminum is widely used in various industrial applications, including the shipping industry, because of its ease of forming, flexibility, and corrosion resistance. The type of aluminum that is usually used for the production of ship equipment is 5000 series and 6000 series of aluminum. With fusion welding methods, welding defect that often occur in the aluminum welding process using this method includes porosity defect and cracks. So, to overcome this problem, a welding process method was developed named solid state welding. It is called friction stir welding, whereas in the welding method, the material to be welded does not melt and is still in a solid state. From the previous research that discusses the role of tool offset on microstructure and mechanical properties of aluminum and copper, friction stir welding joint. The highest peak temperature was obtained when the tool offset was 0 mm. Tool offset greater than 1.6 mm resulted in poor bonding on the weld joint surface and caused crack near the weld joint surface. By selecting the right tool offset can improve the bond performance of weld joint by avoiding the formation of defects such as voids, tunnel, and increasing the interfacial bond strength. This preparation is to analyze the most optional parameter for using offset tool for the use in friction stir welding with aluminum 5083 aluminum base material. And for the tool offset is to increase joint strength by creating vibrations at the tool location during the welding process. Material and methods. Material for this research is aluminum 583 with welded using the friction stir welding methods. The tool in this research is used SKD 61 material, which is steel material, and the tool profile pin is made in a triangular shape. And the dimension of the triangular tool can be seen in figure 3 below. This welding will be carried out using the friction stir welding method by connecting two specimens made from base material. Using the following parameters like tool rotation speed, bit rate, plumb depth, tilt angle, and using a triangular shape pin or quick tool with tool offset variation. For tensile testing in this research was carried out using a contact testing machine ink, and the hardness testing in this research was carried out using a Microvickers FM 800 hardness tester. Result and discussion. It can be seen that the tensile strength value resulting from the friction stir welding process of aluminum 583 with the offset, we can see the highest value of tensile is on 0.2 mm with 216.6 MPa, and the lowest value is 0.4 mm with 127.35 MPa, and the tensile is compared by base material with 186.25 29 MPa. From the research before, that the result of welding 668 series aluminum material using friction stir welding methods with tool offset variation 0 millimeter, 0.2 millimeter, and 0.4 millimeter. So the highest tensile strength result is 181 MPa at tool offset variation of 0.2 millimeter. So the research can be compared by this research. It can be said that in this research, the tool offset variation of 0.2 millimeter is higher than research before. Result and discussion for hardness testing. On the hardness test graph, that the highest value are found in the weld metal area for each variation of tool offset. We can see at the graph the highest value of hardness test is on weld area metal. So it will break in the weld metal area when the specimen is break at tensile test. Conclusion: judging from the tensile strength value of each specimen, the highest average value was obtained for the 0.2 millimeter to offset variation with value of 218.6 MPa, while the lowest average value was obtained for the 0.4 millimeter to offset variation with a value of 127.35 MPa. The result of testing the hardness of each specimen obtained a graph of the hardness value for each tool offset variation. From the hardness value graph, it can be seen that the fracture location of each test specimen during the tensile test was in the weld metal area due to its hardness. Okay, thank you for listening my presentation. Goodbye.
Okay, that's my presentation.
Okay, thank you, Bapak Kriswanto. And we will continue to Bapak Bustomi.
Okay, thank you very
Can you
much
please
for
share your video or
my
direct
PPT.
presentation?
Direct
Okay,
presentation.
Okay, please.
Okay, can you see my PowerPoint in
Yes,
your
we can
screen?
see. Yes, we can see.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Waalaikumsalam.
In this day, we will present my paper with title Performance Test of Brushless Direct Current BLDC Generator in Micro Hydro Power Plant with Archimedes Crow Turbine. I am Muhammad Arif Bustomi and my friend from Department of Physics, Institut Teknologi 10 November, Surabaya, Indonesia. And this is my email. Number one, introduction. The background of our research, the needs for electrical energy continues to increase. Efforts to increase electrical energy production. The BLDC generator has quite good efficient. And the next, the advances of BLDC and the use of BLDC generator as electricity generator is quite promising for the conversion of various potential energy source. And the last point background, BLDC generator can be applied in remote area that requires small scale electrical energy. And BLDC generator can be used generator in micro hydro power plant, and this is the interesting in our research. Research purpose. The research purpose is to determine the power produced by the BLDC generator and the benefit of our research. The result of the research will complement the result of research on a micro hydro power plant And the result of this research can provide additional information. Number 2, methods, tool and material, BLDC generator as test object, LED light as fog light in circuit testing, and multimeter as measure of current, voltage, capacitance, and resistance. And this is the figure of our BLDC our micro hydro power plant in our research. Research flowchart. The first step is turbine torque measurement. The second step, turbine rotation RPM measurement, and the step measurement of voltage and current, and the last step is calculation of electric power. And the completed flowchart in this figure. Number 3, result and discussion. Measurement result data. We have 4 measurement result data. The first is the graph of turbine rotation RPM measurement versus electrical loading. And the second graph is generator voltage versus electric loading. And the graph is generator current versus electric loading. And the last graph is generator voltage versus generator current. And from 4 graph, we made the graph of output power of generator. And this is the graph of generator power versus electrical loading. And from 4 graph, we can make the efficiency of generator. And this is the graph of generator efficiency versus electrical loading. Discussion. The value of the generator electric voltage decrease with increasing electrical loading, but the electrical current increase with increasing electrical loading. And from the all research in my research are consistent with the other research. And generator performance is measured by the comparison of output to input of power. And the maximum efficiency our generator in this research is 22%, and the lowest efficiency in 17%. And from our research, it is necessary to use power storage media such as battery. Conclusion and recommendation. Conclusion. From the research, we have measured the efficiency of our generator, and the value of the efficiency is around 22%. And recommendation, we have 2 recommendations in the next research. The first, it is necessary to reduce power losses, and the second recommendation, it is necessary to study the effect of torque variation on the turbine. And this is 20, and we have 20 reference for this our paper. Thank you very much for your attention.
Thank you very much, Bapak Bustomi. And ladies and gentlemen, we have one more presenters, Ibu Minartiti Santoso. Are you in this room?
Yes, Miss.
Okay, please present your PowerPoint, your presentations, or share your video.
Okay, thank you.
We can hear the voice of the video. Ibu Minar, can you check the audio because I can hear the voice of your video. Okay. Bu Minar, we can hear the voice of your video. Okay.
Okay, Miss.
Ibu Minar, please check your audio. We can hear the voice. And maybe you need the slide share.
uneven drying temperature, less environmental friendliness, high equipment maintenance costs, and complicated method. The modification referred to in the research are changed to unit components that support tool performance with the aim of optimizing tool performance so that it can produce high quality product effectively and efficiently. Modification of the thread cabinet by changing the unit from a gas power thread cabinet to a thread cabinet using electric heating element. The aim of the research is to modify a cabinet dryer to improve the performance of the tool so as to create a more effective and efficient artificial dryer that saves energy so dry tap itself has a simple working method. The research method used is the research and development R&D method. Research and development method are research methods used to produce certain product and test the effectiveness of the product. Development research is a process or step to develop a new product or improve an existing product. The following are the research procedures. This is the set of trial cabinet with heating element. And information in this trial cabinet with heating element, number one is timer, heating element, fan, fuse, temperature control, power, and indicator lamp. And the result of the research is a prototype drive cabinet with heating element. The heating element used is the fine heater shape, namely a heating element with fine tips. The fine heater is tried its shape with a tube length of 50 centimeter with a diameter of 11 millimeter and a voltage of 220 volt and 250 watts. The drive cabinet is equipped with a blower to remove hot and form the cabinet is an effort to speed up the reduction in air temperature. There is a timer to set the drying time and also a temperature sensor to regulate the temperature required for drying. With the tool performance, there is the timer system run normal. Like this, with temperature sensor trial compared with mercury thermometer. In testing the performance of the tool for drying bay leaf, the time need to dry 500 grams of bay leaf was 5 hours at the temperature of 60 Celsius. Drying is even through the vertical location of the heating element. Conclusion: modified dry cabinet with a heating element are more effective than dry cabinet with stove heating. In terms of energy use, a cabinet dry with heating element consumes 250 watts of electrical energy for 5 to 8 hours of use. Cabinet dry with stove heating consumes 3 kilograms of resources in 2 days of use for 5 to 8 hours. Another advantage is that dry cabinet with heating element cannot produce fuel emission like stove heaters, so they are more environmentally friendly. The working procedure for a cabinet dry with a heating element is simpler and safer. There is a button to turn on the unit. Then the blower will automatically rotate to adjust the temperature setting, which can be adjusted according to need, and a timer system to set the drying time is needed. Maintenance of dry cabinet with heating element is cheaper and efficient. Okay, thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the presentations. And we continue with the Q&A session. Any question, Bapak Ibu? Okay, I have question for Bapak Kriswanto. What is the meaning with the tensile strength, and was it the impact of stir welding processes in tensile strength?
Tensile strength is how the specimen is impact in the application industry, and the impact is if the highest tensile strength, the specimen will be more stronger, like that.
Okay, thank you very much for the answer, Bapak Kriswanto. And for Bapak Bustomi,
Yes. Okay.
what is your consideration when applied Archimedes screw turbine in BLDC? Is this turbine already in this in BLDC, or it is additional, what is it, additional component for the BLDC?
Yes. The important application of a BLDC generator for micro hydro power plant, which Archimedes turbine is in produce of electricity in low debit of water. This is the interesting application of micro hydro power plant with Archimedes turbine. Low debit, low debit water. This is the important application. For example, in village, or when the river is not high debit. For example, in water irrigation, for example, in village. This is the important application.
Okay,
In
thank you very
slow.
much.
Sorry, low debit.
Low debit.
Low debit. Yes, low debit.
Thank you very much for the answer. And for Ibu Minar, what is the impact of the modification of heating element in the dryer cabinet?
Okay, thank you, Miss, for your question. Because the tool is limited in laboratory and student need the tool to drying. And I want to increase performance of the tool, so I replace component stove to electric. It's more efficient and effective.
Okay, thank you very much for the answer. Any more
Okay.
questions, Bapak Ibu? Ina? Okay, I think it is the end of the parallel session of Room A. Thank you very much for your participations, for your presentations, and hopefully this seminar will provide benefit for all of us. And see you in the next ISoPA 2025. And
Okay.
Bapak Ibu, in every room, the committee will choose the best presenter, and it will be announced in the website of the ISoPA. So you can see there who is the best presenter of the best presenter and the best paper. The best
Amin,
paper
amin,
for
amin.
all participants. Okay.
Amin, Bu Enda.
Okay. Thank you very much. Thank you very much, Bapak Ibu. And I'm very sorry for all technical issues during the seminar.
Yes.
See you in the next occasions. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi
Wabarakatuh.
wabarakatuh.
Thank you.
Wis, mari.